All right, a couple minutes to go and then we'll get started. Tanya, looks like you made it on okay.
Yes, but I'm not going to use video until absolutely necessary, if that's okay.
No, that's absolutely fine. We understand.
Thanks, Nick.
I would say anybody that has choppy connections and everything, sometimes just turning the video off makes it work a little better. Certainly understand. And I've got 12 o'clock. I'm going to give it one more minute. I didn't try to take roll to see if we've got everybody, but I know we're up to 29 participants, so we must be close, if not everybody. I'm going to wait just a little bit. One more minute. We've started the recording and we've also started the live stream of the event in case others might want to drop in and join us. I'll just say this one more time now. I got most everybody. If you want to go over to open the participant list and hover over your name on the right-hand side off to the line on the right. And when the More button pops up, click on that and then select Rename. And if you could add your landscape or ecosystem after your name, that probably would be more informative to us than the center abbreviation or USGS. Don't have to do this, but it just helps us, especially on the first day when we're all getting used to each other, to remember where we're each from. I think I'm going to go ahead and get started. And just to double check to make sure you all can hear me, can one of you just let me know I'm coming across?
You sound clear, Nick.
All right, good. So first thing I want to do right out of the box is welcome everyone and give you, on behalf of our steering committee, our really heartfelt thanks. We know that all of you are very busy and successful and doing a lot of things at one time, and that you had to work hard to make this time available. That means a lot to us, and I think it's going to make a big deal of difference to what we're actually trying to do. For right now, I think we're going to forego introductions. We had the pre-workshop call. I know not everyone was able to make that. And just remind everyone that the speaker bios are in the SharePoint site. But later on, after we get through this first part, we have a little time set aside. If there's time available, we'll do a quick round of introductions for everyone. But let me start, just say on behalf of our steering committee, we're really excited to have all of you here. And we're especially appreciative, as I've said, of your time and your interest. You are among the best and brightest scientists that USGS has. That's why you're here. You are able to think big. You're able to look at the big picture in addition to being experts at what you do on the ground. And I want to just make it really clear that it's you that will make this workshop productive, all of you that chose to participate. I mean, the organizing committee, we may have come up with the overall idea, and you'll hear more about that, and hopefully did a little bit of the read aheads to see why we're doing this. But all of you are subject matter experts, and it's you who will determine what, if any, tools and approaches we can light on at the end of this 3 days that's applicable across multiple landscapes. Our job as facilitators will be to help keep us on track, but it's you that brings the real value to this discussion and will determine whether or not this idea progresses past this first workshop. We're pretty confident it will, but it's going to depend on you, and we're really optimistic about this. And in a few minutes, Ken Heyer is going to dig deeper into your charge for the next 3 days. But before we do that, let me just go through a couple of ground rules that we always try to do on these virtual meetings. We wish this were in person for obvious reasons, but it's not yet. This will be an intense 3 days, especially today, because we're going to power through a whole bunch of presentations. And the challenge we have for you and all of us is to please stay engaged and listen to these presentations carefully, because we'll be building on that information as we move into the subsequent workshop sessions. As always, keep your audio on mute unless you're ready to speak. As you know, that background noise, I've got a lot of animals in the house. And unfortunately, you're going to hear some of them. I can just guarantee it right now. And I'm sure that will be the case with others as well, and kids and other folks around. But as much as you can, please keep your mute on unless you're ready to speak. And we encourage everyone to keep their video on if you feel comfortable doing so. And if your bandwidth allows, that's great. If you can't, that's fine too. Once we get into the Q&A sessions, and especially the discussion sessions on the second 2 days, it's hard to read body language and facial expressions on Zoom. So we want to work really hard to make sure everyone has an equal opportunity to speak and have input, even those that feel less comfortable doing so. So let's make sure we encourage each other to have input and also not trying to occupy all the space and time. And then those of you who feel less comfortable in jumping on the Zoom, you can use the chat. We'll all be monitoring that if that's easier for you to do. When we get to the part where we have some interactive discussions in Zoom, please raise your hand if you have a question or a comment. And if you hover down at the bottom of your screen, you know that there's a reactions icon there. And if you click on that, that's where you can find the raise hand button. And then when you're done, make sure you go back to that and lower your hand so it doesn't stay up. And just, we'll try to avoid just jumping in without doing that, because there's too many of us to have an unmoderated free-form discussion. We'll be talking over each other. And that'll be difficult, especially for me to do when everything gets really interesting and engaging. But we'll have to stop and remember, let's do a hand raising, and we'll try to take them in order as best we can. As far as Zoom goes, hopefully all of us by now have had enough experience on the various platforms to not have too much of an issue. But just note that in Zoom, the reason we chose Zoom again is we are recording these sessions, and it's also already being live streamed on a separate YouTube channel for observers. And please note and remember that that live stream and the recordings we develop are intended for internal USGS access only, not at this point, and not for public distribution. That way we avoided having to do all the internal review processes. This is just for us inside. This is kind of the sausage making part of this effort. If it's successful, then we may find ways to reach out to stakeholders and others later. I'll also point out that chat will be recorded. Again, we're not going to be distributing that. That's just for our own use in case we have to go back to it and gather some information. And also, I'll think I've mentioned this later, but if you join a little late, just keep in mind the chat that occurred before you joined Zoom, you will not see it. You will only see the chat that occurs after you've joined the meeting. Keep in mind that it's the same Zoom link for all 3 days. And again, please don't share the Zoom link with others. This workshop, we are trying to keep it small enough to be productive, but large enough to get a lot of good ideas in. And then if we get too large, it hinders effective discussion. And so we're recording it so that others can watch it later. We also are doing the live stream, and those folks unfortunately can't jump in and participate, but hopefully we might get some good ideas from them afterwards. Hopefully you're joining via the Zoom app and not the web browser. Some people that have trouble with connections that occur because they mistakenly connected using the browser and not the app. Please, we already mentioned about muting the audio to prevent feedback and background noise. It helps with bandwidth to close other applications and windows you have onto the computer. It's best to do that before you log into Zoom. And just remember, if you lose internet, you can always dial in using the phone numbers in the Zoom invite until you regain connectivity. Also, you'll be posting questions via the chat function sometimes, and other times you'll be raising your hand to ask your question or be recognized to ask your question. Particularly today, we all have pre-recorded presentations. So what I encourage you to do, if you have a question while you're listening to a presentation, go ahead and start posting that in chat. And we will try to we have a 2-minute session after each presentation. I know that's painfully short, but we'll try to pick a few of the chat questions to ask the author. So for this today, you'll be posting questions via chat, but later on during our discussion groups, I think we'll be doing more of the raising hand in Zoom. And I encourage the presenters, while your presentation is playing, monitor the chat so you can see ahead of time what some of the questions are. You can tinker a little bit with Zoom audio and video settings to customize to your preference. The main one I would encourage you all to do is if you hover down to the video icon on the bottom left and choose the little up caret, you'll also see video settings. And if you'll choose video settings, you should have a pop-up window appear on your screen, and scroll all the way down to the bottom using the scroll bar. And you see in gallery view, you can either select 25 maximum participants or 49. Since we have more than 25, I encourage you to click on the 49 so that you see everybody on the same page. Otherwise, you'll have to flip back and forth between two video pages to see everyone. I think we have covered everything, and we will try to stay on track here. Again, I encouraged everyone to either have the agenda open electronically or in hard copy so you can keep up with us and see what's coming up next. But I'm going to turn it over to Ken Heyer to give us our workshop charge and strategy.
Excellent. Thank you, Nick. I presume you can hear me just fine. So good morning and afternoon, everybody. I'm looking forward to meeting a bunch of new folks I don't know yet and interacting with some that I've known for a long time. So my goal is really to cover a couple different pieces today related to the charge. And actually, I'm going to give a little bit of background on the prospectus that got us here. If you wouldn't mind, Breck, would you mind opening that real quick? The prospectus, thanks. So I am, just a quick introduction, I'm the associate coordinator for USGS Chesapeake Bay studies, work with Scott Phillips to coordinate our Chesapeake Bay efforts. And so I'm just going to take a few minutes to really have a goal of giving us this common framework, common foundation. So as long as we start with the same foundation, hopefully it's a great launch point into our 3-day workshop. And so the idea is that our large landscape coordinators have really been working together for some time now. And by large landscape coordinators, this started out being our priority ecosystem studies. So Chesapeake Bay, Everglades, San Francisco Bay, Desert Southwest, and Platte River, but we've really broadened that now. And we're not at all an exclusive club. We're trying to bring in folks that want to work with us across boundaries, across large landscapes. And so Gulf of Mexico, Great Lakes, they're all part of this. And the idea is we've been working together programmatically for some time. And the more we've worked on how we operate, how we interact with stakeholders, the commonalities are just tremendous. We're all working across these large ecosystem restoration efforts. We're probably doing one of the best examples of integrated science across USGS there is. We're blending or blurring mission area lines, program area lines. We're working across, and I'm not going to read through this. I'm just going to hit a couple high points. We're integrating across physical, biological, chemical sciences. So we're really hitting on all the interdisciplinary topics. We're working across temporal and spatial scales. Stakeholder engagement is really a hallmark of how we operate, where all of our science is targeted towards informing management and stakeholder needs. And ultimately, it ends up where we are a highly visible, highly valued, large landscape effort. And you can hang out right there, Breck. And so it's a great example of how we should be doing our USGS work. And so the coordinators have been asking, how can we do more coordination? How can we get into more technical topics? And so really, as we look at sort of across the landscapes and across the horizon, certainly potential effects of climate change, their effects on habitat and habitat vulnerability has been growing interest, becoming an increasingly higher priority. And it really struck us as a topic that cuts across all of these landscape settings. So while the habitats are very different, the living resources are very different, this question of habitat vulnerability to a changing climate is really relevant across all the systems. And ultimately, it's what we're hearing from the managers and the stakeholders, that they need science to drive they need USGS science to drive their management and decision making. And so with that, that's how we've sort of set up this first workshop. When you look at the alignment, should be pretty obvious. This aligns just tremendously well with our administration goals of trying to bring information forward to address the climate crisis. It aligns with the America the Beautiful initiative. We're trying to use some natural conservation to maybe mitigate some climate risks. And then ultimately it aligns really well with USGS mission area goals, agency goals, and even things like our landscape science strategy that the ecosystems missionary put together that said we need to be working these large integrated scales to get this done. So this workshop really reflects the first opportunity by our coordinators to come up with a technical topic that we could look at that cuts across all these landscapes. So the objectives, we're going to come back to these objectives regularly. And I think Nick's quote earlier to us was ruthlessly, to try to keep our focus on this topic. We really want to make sure that we're staying true to the objectives and we keep the end in mind. So the end in mind right now is we want to work to identify either some approaches, some tools or methods that we could begin to connect across landscape settings to apply more generally. And so how are we going to do that? So our objectives here, first one's really easy because we're already making progress. So we want to advance just our communication coordination among the landscapes. So getting you all together to begin to share information across regional boundaries and different programs is huge. So that's going to be very good. With regard to the special emphasis on habitat vulnerability and climate, we want to think, well, what are some of the common vulnerabilities across landscapes? What are some of the common approaches we're taking to address those vulnerabilities? What ways can tools or approaches we're using in one landscape be applied into another? And then ultimately, what outreach products are we using? Coming back to stakeholders, how are we engaging our stakeholders? How are we informing our stakeholders? That's absolutely in play here. And then ultimately, what are the opportunities for extrapolating from either individual studies to other landscape areas or even to unmonitored landscape areas? Because ultimately, we want to look at the opportunities there to apply our science across the entire area. So with that, I'll end on this session and we'll jump into the charge with this idea of we want to keep the end in mind. So we're going to spend 3 days together. We're going to start very broad with our presentations. And by the end of 3 days, we really want to have a refined list that says, here are some of the priority activities we could take up next to really have that next step of how we connect across landscapes. It could be a model, it could be a framework, it could be a tool or an approach. We're not sure yet. And that's where, as Nick said, we're going to rely on you to help steer us through this process. And then ultimately, we'll see if there's an outreach document that the coordinators take on putting together. Maybe, maybe not, but we'll see. So here's our charge. You can see we started with the goal of the workshop, which I've already mentioned, that we're trying to identify one or multiple opportunities to advance approaches and tools. And so how are we going to do that? So the prospectus really laid out, what are we trying to do? This is the how. And so I'll briefly buzz through this. So we provided read ahead materials to you all. Hopefully everyone's already looked at them. If not, please make time to look at them later on today. The idea is we know we only have about 15 or 16 contact hours, and cutting across all the different landscapes and all the different science topics, we couldn't cover everything. So we wound up using the read ahead materials to include bios, to include landscape summaries. Please take a look at those if you haven't. Next, Nick began to mention this. You all have been selected not just because you're exceptional in your field or in your respective landscape, but for your ability to think big picture across landscapes. We're really going to ask everybody to sort of take off your regional hat or take off just your particular landscape hat and think about how do we connect these dots a little better and bring that information to us. Give us that big picture thinking. We're really going to benefit from that. Go ahead and scroll down, please, Breck. So stakeholder connection, stakeholder engagement is certainly in the field of play this week. So we want to make sure we're understanding how your science is contributing, how you're engaging your stakeholders, so that we're all learning from that and benefiting from that. So the stakeholder piece it's a hallmark of our large landscape efforts. So we definitely want to hear from you about that. And then please participate in the full workshop. We really have tried to make sure we're getting people that can participate all 3 days so that you see all the presentations. Then we build from the presentations with a really rich discussion on day 2, and then we prioritize. So please participate in all those discussions with us. Nick also mentioned we're going to try to have a series of opportunities for discussion and your input, and we're going to have the chat functions going to be open, and we're even going to use some Jamboard discussions. So please work to give us that thinking, give us your input. I'd approach it that we're going to try to craft a safe space here so that we can get all those ideas down and sift through them, and the coordinators are going to work each night to sort of go over some of the ideas and try to refine thinking, summarize some things, synthesize some things, and then bring them back to the group for day 2 and day 3. So we're going to be working on that. So we hope your thinking doesn't stop at the end of each day. Keep thinking about ways to connect between these landscape settings, whether it's your approach or whether an existing tool or certain data sets can be connected. So with that, that wraps up the charge. A couple more quick pieces I want to introduce today. Sharing content with us and helping us basically run today's entire workshop is going to be Breck Sullivan. Breck's a scientist in our Chesapeake Bay landscape. And so if you have any issues or challenges with accessing the Jamboard, accessing a Menti, I'll encourage you to reach out. You can certainly reach out to any of the coordinators, but Breck is going to be a really key piece to implementing this whole workshop. So always feel free to reach out to Breck if you need help with any of the Jamboard, chat, Menti, that sort of thing. And then lastly, I'll sort of wrap up. Okay, excellent, Nick. I'll wrap up here in just a minute. So as far as wrapping up with the agenda, and I kind of mentioned this, today is, and Nick did too, today is going to be very intense because we're going through about 14 or 15 different presentations. Not going to have a tremendous opportunity for discussion today, but day 2 and day 3 are really set up for full discussion. And so day 2, you're going to have an opportunity to ask your questions, dig a little bit deeper into certain presentations and certain methods and approaches. It'll be more of a brainstorming opportunity so we can throw ideas out and build on those ideas. And then day 3, we're going to try to refine that a little bit more. And we're going to start maybe prioritizing some items and thinking about level of effort that it would take. And so we'll try to refine on day 3 to kind of pull it all together so that when we leave the workshop, we've got this more refined, focused list of next steps we could take forward and that we could build an entire second workshop around. So I'll pause there. And I think, Nick, we were going to open up a discussion session, but I'll hand it back to you.
Thanks a lot. That was great. And he reminded me that I forgot to introduce myself when I started. My name is Nick Allman. I'm a regional science advisor in the Southeast region. I live in the West Palm Beach area. And my main day job is coordinating the Greater Everglades Priority Ecosystem Sciences program. But then other things, along with some of my colleagues like Greg Steyer, we organize a yearly Southeast region science workshop, which will be already have started on the planning for that. So I just want to take a moment to introduce myself. I'm going to turn it over to John now, Hortness, and I'll let him introduce himself. And what we're going to do now is give you a chance to ask us any questions or make comments about our workshop charge, because I think we all want to be at the same place in understanding what we're doing as we move forward. So it's important if you have some uncertainties, if you weren't able to attend the pre-workshop call or read the read-ahead materials as deeply as you might have liked, this is a good opportunity to do that. And we will also, depending on how much time that takes at the end of this 12:30 to 1 o'clock period, we're a little ahead of schedule, which is good. We'll do our introductions of everybody. We'll go around the room if we have time and make sure everybody has a chance to introduce themselves and say hello. We will stay on time in the sense that even if we end this session early, we're not going to start the presentations until 1 p.m. Eastern time. The reason for that is, again, we may have folks on the live stream that come on for specific presentations. So we'll just take a little longer break if we need to before 1 o'clock. I just went over to the live stream quickly to look at it, and there's already 10 people watching. We don't know who they are, but there are 10 folks on that already. So John, I'm going to turn it over to you to moderate this next session, and I would ask people to have questions just to raise your hand, and maybe Breck, if you can stop screen sharing, we'll be able to see everybody as well. John?
All right, great. Thanks, Nick. So yeah, John Hortness. I'm with the Mid-Continent region. I'm the regional Great Lakes program coordinator, and I also big part of my job is actually to facilitate and coordinate all of our efforts under the Great Lakes Restoration Initiative. And so that is not just a Mid-Continent region effort that encompasses Mid-Continent, Northeast region staff and centers, as well as we actually have a lot of projects that go out across the country to support a lot of the Great Lakes restoration work. So I'm extremely interested to see how this all turns out over the next 3 days. I think there's a lot of opportunities for collaboration in the future. So as Ken noted, today is pretty structured. We've got a lot to get in, but what we do have over the next 35 minutes is a little bit of free time to give us a chance to make sure everyone's on the same page, set the stage, make sure we're all starting from that same understanding of where we are, where we're trying to get by, Friday late afternoon. So with that in mind, I guess let's start with, do you have questions on the strategy, the charge? What are we doing here? Why are we doing this? Anything that Ken mentioned or Nick mentioned in the intro. And let's just have a little bit of a conversation, if we need to, on kind of the status. Where are we and where are we going? Just to make sure, again, we're all on the same starting point so that we have a successful process over the next 3 days. So with that, let me open it up. Please raise hands and we'll see what kind of questions we have. And feel free to even just provide any comments on what you think about this process. So like I said, this is our free time today. This is about the only free time we'll have to really have an open-ended conversation. So let's take advantage of it now, and then we'll get into the hard stuff here in a little bit. So let's start. Karen, you have your hand up, so go ahead, please.
Hi, Karen Thorne. I'm in San Francisco Bay. So I have two just sort of general questions, and I'll jump right in. Are we looking for more than one idea? And every priority landscape or some priority landscape? So of course I'm a scientist, I go straight to the details, right? What exactly do you want me to do? And you probably don't have an answer, I'm assuming, but maybe you have. Obviously you guys have been talking about this longer. You probably have come up with those same questions. I'm curious on what your thoughts are.
So I'll start, and then I'll ask the others to chime in as well. I think it depends. I think it depends a lot on all of you and what these discussions look like over the next 3 days. I think in a perfect world, we would find something that encompasses all the landscapes. We spent a lot of time talking about that, thinking about what is something that everyone can have a piece of, or at least be at a point where you can have a specific conversation and an interest in a topic. So I think that's first and foremost. But again, I think it also depends on where we are over the next couple of days, and the process that we're hoping to go through ideally will get us to that point of identifying, and I don't think it's just one, maybe one bubbles to the top and it's obvious to everyone that's where we need to go next, or maybe it's a handful of things, and that's what we'll get to, in the Friday sessions, is start to get to that point, zero in on potentially, maybe it's, I think we've been kind of chatting about 3 to 5, but there's a lot of unknowns between now and then. So I think it depends, which isn't a very satisfying response, but I think we'll kind of map that out as we go. So any other of the coordinators, any other comments to that?
I'll add just a little to that. That's exactly right what John said. We have no preconceived number. What we do want to do is make sure that what we end up with is we're viewing this as a pilot project, a proof of concept. And so we're looking for things that are relatively easy to do in short time frames, not a brand new effort that would take multiple years to get to. We want to see if this cross-fertilization effort we have really works and is feasible. So that may influence the bottom line and the total number we light on at the end of 3 days. But right now, we're kind of leaving that open. We certainly hope, I would like to get more than one, just so that we have a couple more that we can work on. But, that will depend on a lot of things that we come up with. Greg or John, Greg or Ken, you have anything else you want to add to that?
I guess the only thing I'd add, agree fully with John and with Nick, and without previewing too much, I think Wednesday, when we think about how we prioritize some pieces, we will do some prioritization, but we're certainly not going to be throwing things out that maybe don't hit on our highest priorities right now. So one of the things we'll want to do is organize our thinking, and it'd be great if we land on 3 to 5, but I can see some other categories or bins already forming that we might think about either for some longer term pieces, because as Nick hit on, we're trying to take the ongoing work we have now, the resources we have now, and leverage that. But maybe there are some longer term options, and maybe there are even some shorter term pieces that kind of easy wins, if you will, that we say, let's move out on those now. So we will try to organize and prioritize, but we're also not going to throw ideas out because I know how much peer-to-peer, scientist-to-scientist coordination can also go on. So great question. Thanks, Karen.
Yeah, thanks.
Yeah, thanks, Ken. And Mike, go ahead. You have some comments too.
Yeah, well, I just wanted to add on top of the other comments, which I think we're all on the same page here, that we really want to think with an open mind at this event, Karen, and there will be various filters that we'll be applying to the ideas that we hear at this event. But I think we should start with, broadly open minds, and then we'll have a discussion about each of the filters that we want to apply as we go forward. So we will be able to have some dialogue as to the advisability of making choices along the lines of, how many systems could participate if we pursued this question, and, how many projects can we reasonably implement, et cetera. So I think we will be able to make sure everyone is involved, including parties that aren't present at this meeting. As we try to narrow this down over time into something that we actually can put into the field.
Thanks.
Great. While we're waiting for more hands, there were 2 more Zoom tips I neglected to mention. If you go all the way up to the top right where you see the view button and click on that, you can either choose a speaker view, which means you see the speaker highlighted in the larger screen. I keep mine on gallery view just because it's easier, but when we go to share screen, it goes back to kind of a speaker view. The other quick thing I'll add is that you'll find that if you have more than one monitor and your cursor is on that screen, you can use your space bar to unmute yourself. Just hold it down and you will be unmuted when you hold the space bar down and talk. Or if you hover your cursor and leave it over the mute button, the space bar will turn mute on and off. So I just want to throw that 2 cents in of trivia. Any other questions and comments? We should use this time as much as we can. I'm fully hoping that you guys will bring up something we have no clue about, that we hadn't thought about in the weeks and months we've been prepping this. So, that's why we're open-minded. We don't know where in the end this is going to lead us. So, and you might lead us in some new and exciting directions. So keep that in mind. Anybody else?
Okay, Tanya, go ahead.
So as we're sitting here talking, it occurs to me that, there are probably other methods that I didn't get to include in my 10 minutes. And so I guess I can look for ways to interject those, and some of them, I guess just kind of a thought that hopefully we'll get to be able to pitch methods that we didn't get to summarize maybe.
Absolutely. And I think what you'll see, Tanya, and everyone, is that's essentially where we start tomorrow, is taking advantage of what we heard. And we knew going in, we were not going to get everything from every landscape. We have 2 people in each landscape. And as much as you can try to focus on the bigger things, you also still have a focus on the work that you're doing. And like Mike noted, there are other folks, that aren't able to join today, or we weren't able to fit in, that have other efforts they work on that could be very relevant, likely will be very relevant. So that is the process that we'll go through starting tomorrow, is to take what we've heard plus add in all of those other ideas and potential options. And I think the thing that Ken said is really important. Even if we get to a point on Friday where we have a near-term plan, we're going to learn a lot of other things throughout this process that we're going to be able to take advantage of for whether it's future workshops or future collaborations down the road. So there's going to be a lot of really good information coming out of this that will be usable in multiple places, at least in my mind. And I don't know, Ken, anything you want to add as far as you're kind of leading the process tomorrow to kind of start to, or I'm sorry, on Friday to kind of start to whittle it down. But any other thoughts on the, parking lots and how we're going to make sure we keep tabs on all of those other pieces?
Yeah, I think you're spot on, John, and that's it. We're going to have a couple tools that we can use, whether they're parking lots, whether it's some Jamboard opportunities, whether it's Mentimeter. And that's even why I said we're not sure what the final product is going to look like, whether it makes sense to write up a formal document or whether it just becomes sort of a list of opportunities that we want to move forward with. So I appreciate the questions, because this is what we wanted to do, is make sure folks weren't seeing this as too limited from the beginning, whether it's Tanya, your comment about there's other methods, we knew that. But we also wanted to keep the size manageable enough that if we had 100 people, we knew we just, we wouldn't get the structure out of it we'd hoped for. So great questions.
Thanks, Ken. Any other questions? So maybe while you're thinking, I'm going to ask Zach maybe to provide a couple of comments. Zach is our landscape program coordinator, and I probably butchered your title, Zach, but please chime in, give us some overview. You've chatted with our group a bit about this process and what we're trying to accomplish. And so I think maybe folks be curious to kind of see or hear from your perspective, how does this fit in kind of the bigger picture that you've been working on in your day job?
Well, thank you very much. And first thing I'd like to do is just recognize all the effort that the coordinators have put into this. This process started a while ago, and there's been a lot of careful thought, and Nick et al. Have done a wonderful job pulling it together. And I'm real excited about seeing what comes from this, because the PES priority landscapes projects really are exemplars of what USGS has been, big USGS has been working to do since I came into the agency a long time ago. And that's do a better job with integrated science. And what I think is really wonderful is we have these exemplars that y'all are all responsible for. And the key is they're partner driven and place based. That's what makes a difference with relevance, I think. It gets harder for us to maintain that relevance to specific issues when we look across the nation. One of the things that Ann and the execs are interested in is how can we do that with some of our ecosystem science? Well, I think the answer is right here amongst y'all, because what you're doing, the place-based work, is at the right scale to maintain the local relevance, but it is also through activities like we're talking about here, possible to pull across these different geographies, some themes and some actual science-based questions that are going to be really important to the nation. And people are looking for us to help answer these questions now. And this includes the administration. They have ideas for America the Beautiful, a national nature assessment that's going to be analogous to a national climate assessment. And the work that you're doing just fits very nicely into these broader designs that people have had for a while within USGS and this current administration has. And as you note by the longevity of the work that's gone on in many of these places, it's transcended lots of different views from the White House and Congress and so forth, because it's relevant and it's based on the needs of real people in real places. So I'd encourage y'all, as you're listening to the talks and thinking about what you can do, to consider how you can knit together parts and pieces from your individual efforts and really make something that contributes nationally. And I'm sure you can. There's probably lots of different things that are floating in people's minds. And I think Nick had a really good, or maybe it wasn't Nick, somebody said, let's try to look at this as a pilot and try to get something that clicks. And I would encourage that too, with the idea there are going to be a lot of things that float to the top. And if we can intersect the two circles of what's the most useful, relevant, important thing that we could do with what's feasible in a reasonable amount of time and hone in on that. Those might be some things to think about. As John said, USGS, I should have said, I'm the Land Management Research Program Coordinator. I'm one of the coordinators in GS, and there's 20 something of us now, I think. But we recently published a landscape science strategy, and I'm sure everybody's read it backwards and front to understand it completely. But if you haven't, I'll put it in the chat, and it's USGS Circular 1484. It's got a lot of the same ideas that the leads were introducing this with, and I'd encourage you to take a look at it, think about it. It's basically the same integrated science ideas and approaches USGS has been talking about for a while. We're really close to actually doing it in the work that you're doing here, and I'm just real excited to see what comes out of this. So thank you, everybody, for your work and your time invested here.
Great, thanks, Zach. I appreciate that. So with that, did that promote any other questions or thoughts from the group? Even any questions for Zach? I'll throw him under the bus here quick if anybody has a question for him. Okay, so seeing none, I think, I guess I would just mention one more thing, and I'm going to reiterate, I think, what Ken said a bit ago, and Zach kind of alluded to it. This is your opportunity to take off your center/region hat and really think big. You know, we're giving you freedom to think big for the next 3 days, and don't get caught up in what you're doing locally or regionally. You know, step out of that box and think about what might be possible, and forget about any constraints, whether it's funding or feasibility or staff or whatever. And let's just think about what may be possible. And then we'll start to put those sideboards on later to see where we might go. But I think that maybe, from me, that might be my challenge for the next 3 days, is for you all to step out of that box and let's just really think big and see where we might go. Nick, go ahead.
I just would point out that I know Zach mentioned Priority Ecosystem Sciences program, but we also included, I think you can see from here that we've included some other large landscape efforts that may not necessarily be formally PES programs, because we wanted to pool the thinking at that kind of scale. So I just wanted to mention that briefly, that we're a large tent and we can make it larger if we need to. This was just trying to get a similar group of folks together that work at a similar scale.
Yeah, thank you, Nick. And that's the idea within the program anyway. When we talk about it, we refer to things as priority landscapes, and there are a lot of them. So thank you.
Okay, Neil, I think your hand is up.
Yeah, I think this might be a silly question, but the more I roll it over my head, maybe it's not. I wonder, is it important to make a distinction at some point between terrestrial versus aquatic? Because I'm just thinking about extrapolating certain methods that work across terrestrial landscapes and even coastal, vegetated landscapes, but would not work so well in tidal or, lake systems. So I don't know. I'm just throwing that out there. Should we try to preemptively constrain ourselves to kind of subaerial lands and not anything that's subtidal or underwater all the time?
So I'll give you my 2 cents. You're asking the questions that we, bounced around for weeks as the coordinators, trying to figure out where should we set constraints, where should we leave open-ended. I think for now, my preference is we don't put those constraints on anything. Let's put it all in the hopper, see where it takes us. At some point, we'll likely have to put those constraints out there, but for now, let's not get too caught up in a path or a roadmap forward. Let's really leave it really open-ended. And again, that's my 2 cents. I saw a thumbs up from Mike, but any other comments from the coordinators?
I think that's perfect. When I was listening, I think we've listened to all the talks, and I was amazed at some techniques and things that happened in one, like an aquatic landscape, that would work in a terrestrial that I hadn't thought of before. I think we'll see some of that. when we get down to the final list, I would imagine we might have some that are most relevant to one or the other of those, and we'll let that sort itself out as we go along. Mike has his hand up.
Mike, your hand's up.
Yeah, and Neil, we definitely do not want to lock ourselves into thinking about only, elements of the ecosystems. When we were having some of our dialogue in preparation for this event, several of us, including me, kind of found ourselves gravitating toward thinking about things that are important in tidal marshes, where, for example, sea level rise is going to be a huge issue, but that, of course, is not going to be an issue for upland ecosystems in areas that are in the interior of the continent. And we definitely don't want to find ourselves being captured that way. So we really do want to think broadly about everything that's relevant.
Except all the sea level rise migrants that will move to the upland ecosystems and cause additional impacts.
Okay, one last call for questions or just general comments. Okay, so we'll keep thinking. What I want to do next is there's a handful of the coordinators that haven't had a chance to introduce themselves yet. So I want to start with them, and we'll do a quick intro. So Greg, are you able to provide just a quick intro for yourself?
Sure. And good afternoon, everyone. I'm Greg Steyer. I'm the Southeast Region Science Advisor, and I coordinate science in the Gulf of Mexico region. And really looking forward to looking for those commonalities, whether you're on the Pacific, Atlantic, Great Lakes, or Gulf, as it relates to the work that we're all doing. So welcome to everybody.
Great, thanks, Greg. And Mike, I know you've talked already, but I don't think you've actually introduced yourself.
Yeah, good morning, everybody. I know a lot of you. I'm Mike Chakowski. I'm the science coordinator for the Southwest region, and I primarily work in the San Francisco Bay Delta. And I manage the San Francisco Bay Delta PES.
And Aaron, you want to go next?
Certainly. Hi, everyone. Excuse me. I'm Aaron Pierce. I'm a research scientist at Northern Prairie Wildlife Research Center, and I'm one of the lead scientists for the Platte River and expanded kind of mid-continent priority ecosystem.
Thanks, Aaron. Bill, why don't you go next?
Hi, I'm Bill Labiosa. I'm Regional Science Coordinator for the Northwest and Pacific Islands region. I serve as the Puget Sound PES Coordinator. Our resources are a little bit lower than some of the other guys on here, so I have some free time. And in that free time, half of my job is working for EPA through an agreement. And in that role, I chair the Federal Science and Monitoring Work Group for the Puget Sound Federal Task Force. And what I find is wearing the EPA hat and the USGS hat is actually leading to some additional resources for USGS to support Puget Sound recovery. So it's, it's working out, that kind of dual arrangement. Okay, welcome everyone.
Thanks, Bill. Mike, go ahead.
Good morning or good afternoon, everybody. I'm Mike Dunaway. I'm a research ecologist with the Southwest Biological Science Center here in Moab, Utah, and I spearhead the Southwest Desert PES program. And myself and those that were able to attend from the Southwest Desert program are pretty excited to be here. And, we're pretty different than a lot of the other systems since we're very dry, but I think there's a lot of commonalities that we'll find from the talks you'll hear from our group. And I'm excited to hear what everybody else is up to. Thanks.
Thanks, Mike. And then Robert Gleason, are you there? Perfect.
Thank you, everyone, and good morning, good afternoon. Really looking forward to the outcomes of this meeting. I am Center Director at Northern Prairie Wildlife Research Center in Jamestown, North Dakota, and I sort of coordinate this with Aaron Pierce in the Mid-Continent Platte Priority Ecosystem. Thank you.
Great, thanks, Robert. So I think I hit all of the coordinators. You already heard from Zach. And so then I want to go to Claudia, who's also representing a portion of the mission area.
Thank you, John. Good morning, everyone. I'm Claudia Mengelt. I'm with Ecosystem Mission Area in SAC's program, a land management research program. I support SAC in everything related to America the Beautiful. And more generally, I'm really interested in figuring out how we can do co-production across everything we do in our program and making sure that we find venues to apply all the great research we're doing in USGS to decision-making and share the information with our partners in DOI and others. And as Zach alluded to, I think learning from your many years of experience in that realm of co-production is what I'm most excited about over the next 3 days, to really learn how you're undertaking applied research. So yeah, fantastic meeting you put together. So really looking forward to learning and listening in.
Great, thanks, Claudia. So I think we have enough time where we can just go through all of the other participants and just, similar, just very quick intro, who you are, where you're sitting, and maybe just a quick mention of whether it's your current effort, research interest, whatever it might be. So I'm going to go right down the list. So let's start with Camille.
Hello, everybody. My name is Camille Stagg. I am a research ecologist at the Wetland and Aquatic Research Center in Lafayette, Louisiana. And today my talk is focusing on Gulf of Mexico research and coastal wetlands. And I'm really excited to learn about all of these other ecosystems from you guys this week. Thanks.
Great, thank you. Then actually, I want to circle back really quick. I apologize. And Ken mentioned Breck Sullivan from the Chesapeake Bay program is really helping us with all of the support, logistics, everything. So Breck, could you please introduce yourself quickly? Apologies for skipping over you.
No worries. Thank you, John. Yes, I'm Breck Sullivan. I'm with the USGS at the Maryland, Delaware, DC Water Science Center. I too wear an EPA hat through an interagency agreement. And so I serve as a scientific coordinator at the Chesapeake Bay program to help coordinate the science that's going on, to help explain and communicate the changes going on in the Bay. So thank you.
Great, thanks, Breck. All right, let's work down the list. How about Dave Beauchamp?
Hi, yeah, I'm Dave Beauchamp. I'm the chief of the ecology section at the Western Fisheries Research Center. Our program looks a lot at food web ecology, largely from a bioenergetics perspective, with kind of the focal species being either anadromous salmonids or resident forms of those, and we'll work in marine and freshwater and estuarine settings there.
Great, thank you, Dave. Davina?
Hi, everyone. I'm Davina Passeri. I am a research oceanographer at the St. Petersburg Coastal and Marine Science Center in Florida. And my research is really focused on understanding the effects of sea level rise in coastal environments like barrier islands and estuaries.
Great, thank you. Let's go to Eric Grossman.
Hi there, Eric Grossman. I'm a research geologist, oceanographer with the Pacific Coastal and Marine Science Center in Santa Cruz, California, but I sit up in Washington in Bellingham at the Western Washington University. I spent half of my career on coral reefs, beautiful tropical clear waters, and then moved into very muddy Solistoclastic delta systems. So you'll hear some of our work on just watershed sediment transport issues and coastal geomorphic habitat change.
Great, thanks, Eric. John Bradford.
Hi, everyone. I'm John Bradford. I'm a research ecologist with the Southwest Biological Science Center. I'm located in Flagstaff, Arizona. I am part of and contribute to the Southwest Deserts PES. My work really focuses on understanding climate change and patterns of drought, ecologically relevant drought in upland ecosystems, particularly dryland water limited ecosystems, and helping DOI resource managers think about what those patterns and trends mean and how they can adapt their management to sustain these vulnerable ecosystems in coming decades.
Great, thanks, John. Judy Drexler.
Hi, everyone. I'm Judy Drexler. I'm a wetland ecologist at the California Water Science Center in Sacramento, and that's in the San Francisco Bay Delta region. I do a lot of work on the sustainability of wetlands under all kinds of disturbance. Lately, a lot of it is climate change and sea level rise. I'm also doing a lot of the science behind restoration. How are restored wetlands or other aquatic systems doing, and how can we understand their progress, and what can we do if they're not progressing as we expect? I'm also really glad to be here. I'm very excited to learn from everyone, and I'm just really grateful for the opportunity.
Thanks, Judy. Karen Thorne.
Hi, Karen Thorne. I'm a research ecologist, and I work at the Western Ecological Research Center. I'm based in Davis, California. I am an ecologist that is looking at understanding how climate change and sea level rise is impacting estuaries and wetlands and other nearshore ecosystems, and what that means for restoration, management of species, and overall, it seems everything gets put into the bucket after a while. So yeah, I look forward to working with everyone over the next few days.
Thanks, Karen. Let's see, Kelly Maloney.
Hi, everybody. Kelly Maloney. I'm in the Eastern Ecological Science Center, which recently merged to Leetown and Patuxent. So if you're not familiar with that name, recent merger. I'm based at Leetown, West Virginia. I'm an aquatic ecologist. My research looks at past, present, and future land use and climate and vulnerability assessments on freshwater ecosystems. And I'm involved in a lot of different aspects from biology to abiotic. Couple teams I'm working on. I'm on a science planning team with Ken, and you're leading the regional assessments and status and trends, or at least part of them. So.
Great, thanks, Kelly. Kurt Kowalski.
Good afternoon, everybody. Kirk Kowalski at Great Lakes Science Center. John, I really look forward to learning more about desert systems, and Seth, I see you have that in your title, and others, because there's a lot of wetlands people on this call, which is really exciting to me. I think that's pretty cool. But my focus is Great Lakes coastal wetlands, all freshwater work. And as you'll hear from my talk, I'll talk about the ecology and management of those systems, but then also a research program with non-native Phragmites australis and other invasive plants as we think about new control strategies for those plants.
Thanks, Kurt. Mike Anto.
Yeah, Mike Anto. I'm a research scientist and branch chief of the Wildlife and Ecosystems branch at Northern Prairie Wildlife Research Center. My research focus is largely on migratory birds and the habitats they depend on, particularly wetland ecosystems. Within the branch I supervise, we have a real heavy focus on migratory birds as well.
Great, thanks, Mike. Michael Oslin.
Hello, greetings from Louisiana. My name is Mike Oslin. I'm a research ecologist at the Wetland and Aquatic Research Center in Lafayette, Louisiana. And I'm another wetland ecologist. I work mostly in coastal wetlands, and so that includes mangrove forests of the Everglades, and also the different kind of wetlands across the Gulf of Mexico, salt marshes, and also in our more arid coastal wetlands, we have salt flats.
Thanks, Mike. And note, there's 4 mics on the call today, so we'll struggle. You actually beat the Johns today. Let's see, next, Neil Ganju.
Hi, I'm Neil Ganju, oceanographer at the Woods Hole Coastal Marine Science Center. Our group works primarily on the intersection between hydrodynamics, sediment transport, and geomorphology. And so that has kind of brought us into salt marshes in the last 5 to 10 years, and using some remote sensing and numerical modeling approaches to deal with their stability and future trajectory.
Great, thanks, Neil. Owen McKenna.
Hi, I'm Owen McKenna, and I'm a research ecologist at Northern Prairie Wildlife Research Center. And I'm also have a detail as a visiting scientist with the Midwest Climate Adaptation Science Center. And that's where I'm joining you from St. Paul, Minnesota. My research focus is mostly ecosystem ecology type questions surrounding wetlands. And the system that I study mostly is the prairie pothole region and prairie pothole wetlands. and sort of that overlap with the upper Mississippi River Basin. And yeah, excited to be here.
Great, thanks, Owen. Sasha?
Hi, everybody. I'm Sasha Reed. I'm a research ecologist with the Southwest Biological Science Center. I am pumped to be here and hear about all these wet systems, all the water you guys get to enjoy that we wish we had. I am an ecosystem ecologist also, and I love working with our manager partners to better understand how changes like climate change and land use change and management options affect ecosystems and will affect them into the future. And not only the depressing science of how things are changing in ways we wish they weren't, but the optimistic science of what options we have and what tools we can provide to try to address those changes head on and together. Thanks.
Great, thanks, Sasha. And I think we have 2 or 3 left, and we'll cycle right into our next session. So timing should be right on. Seth Munson.
Hey everyone, my name is Seth Munson. I'm a dryland plant and ecosystem ecologist at the same center as Sasha, and I represent the Southwest Deserts group.
Great, thanks, Seth. And Stephanie?
So I'm Stephanie Romagnac. I'm a research ecologist in the Everglades at the Wetland and Aquatic Research Center. I'm based in South Florida, and my team does a lot of development of decision support tools, very often through developing predictive ecological models for our agency partners as they're trying to make decisions toward restoration, action, implementation, and conservation planning.
Great, thanks, Stephanie. And Tanya Williamson.
Hello, I'm Tanya Williamson. I'm a research hydrologist currently with the Ohio, Indiana, Kentucky Water Science Center, where I get to work quite a bit with the streams of the Maumee River Basin, as well as others within the Great Lakes and Midwest. What may be obvious by the end of my talk is that I'm actually trained as a soil water scientist, a pedologist, and I trained in the drier landscapes. So I'm looking forward to hearing a little bit about them as we move forward. It's nice to meet you all.
Great, thank you, Tanya. All right, so perfect timing, folks. Thanks very much. I think that was well worth the time to kind of make sure everyone is kind of clear on where we are, where we're starting. We got a chance to have that little intro session, and now we're ready to start our first session of talks. And I see Breck is working right now to bring them up. So as Nick mentioned earlier, the way this will work is we will play those series of pre-recorded presentations. After each recording, we'll have a couple minutes to answer any maybe clarifying questions, or just get a little urgent question out if you have one for the presenter. Please put those in the chat as you're watching if those come up for you. And then at the end of the first 5 talks, we will have about a 15-minute session where we can actually have a little more Q&A, maybe a little more detailed conversation around those specific presentations. And that's going to be basically the plan for this afternoon. We're going to have 3 sessions of presentations, 5 or 6 each, a very small amount of time during the transition for 1 or 2 questions, and then about a 15-minute closeout for each of those sessions where we can have a little more detailed discussion. So with that, I'll ask Breck, if you're ready, let's go ahead and bring up that first presentation and we'll get started.
Hello, my name is Camille Stagg. I am a coastal wetland ecologist at the Wetland and Aquatic Research Center in Lafayette, Louisiana. Today, I'll be presenting research from our center and across the northern Gulf of Mexico that focuses on quantifying ecological thresholds in coastal wetlands and linking those thresholds to the landscape to support coastal wetland restoration. In parts of the northern Gulf of Mexico, high rates of land subsidence and relative sea level rise have led to marsh decline, fragmentation, and ultimately conversion to open water. And so coastal managers are increasingly challenged to identify opportunities to restore degraded marsh to enhance their ability to keep pace with sea level rise. In addition to sea level rise, storm events such as hurricanes play a critical role in sculpting coastal wetland development and degradation. With climate change, storms are expected to increase in intensity with more frequent extreme storm events. Extreme hurricanes are bigger and stronger with higher wind speeds and larger wind fields. These storms will also be wetter in that they will produce extreme and record-breaking levels of rain. So extreme precipitation associated with or without hurricanes can have a major impact on human communities, and it can also affect coastal wetland health. An example of this is Hurricane Harvey, which produced record-breaking amounts of precipitation along the Texas Gulf Coast in 2017. So all of these climate-associated drivers can alter wetland hydrology, which disrupts the critical process of wetland elevation gain. Lots of previous research has shown that marsh resilience to sea level rise is partially dependent on positive biogeomorphic feedbacks between flooding, plant growth, and sedimentation, which allows marshes to adjust their soil surface elevation in response to rising sea levels. And so disruption of these feedbacks by sea level rise, precipitation, storm surge, or any excessive flooding event can lead to marsh collapse and habitat loss. And so restoration efforts often seek to maximize these feedbacks to increase marsh elevation. The Northern Gulf of Mexico has many active and robust restoration programs along the entire coast. A couple of the large-scale methods used to restore coastal wetlands include river diversions. An example of that is on the left, where large rivers such as the Mississippi River are diverted to create wetland habitat. And also on the right, beneficial use of dredged sediments. And so these restoration techniques focus on providing sediment to the wetland to increase marsh elevation and restore optimal flooding conditions. The beneficial use of dredged sediments has proven successful in restoring ecological function to coastal wetlands, but managers need more data to inform two key decisions for implementation of these restoration techniques. The first is elevation targets. What is the optimal elevation to generate desired ecological function? The second is site prioritization. Which wetlands are most vulnerable to climate change? Which wetlands should be prioritized? And so first we'll look at elevation targets. Quantification of elevation thresholds in coastal wetlands can provide the data needed to answer these questions. Ecological thresholds are common in ecosystems and can be used to identify critical zones of change. For example, in coastal wetlands, elevation thresholds control the conversion from a healthy vegetated marsh to open water. At optimal elevations, wetland plant production is highest and production declines with decreasing elevation. And because this relationship is nonlinear, we observe large changes in plant productivity with relatively small changes in elevation within this threshold zone. So beyond the threshold, we observe a sudden and dramatic decline in production with subsequent conversion to open water or marsh collapse. And elevation thresholds can be used to inform restoration activities to identify targets for optimal elevation. They can also be used to assess vulnerability. So we've quantified these relationships in coastal wetlands along the Texas coast. This is an example from San Bernard National Wildlife Refuge. In these coastal marshes, succulents were found at higher elevations, and Spartina alterniflora was found at lower elevations. The threshold here identifies the elevation beyond which marsh will convert to open water. And in terms of restoration, elevation targets should be above this threshold for Spartina alterniflora. And as an indicator of wetland vulnerability to increases in flooding, this relationship represents how slow incremental increases in flooding, such as sea level rise, can lead to marsh collapse.
So once sea levels increase above this threshold, we can expect Spartina alterniflora marshes to convert to open water. However, we have found that these relationships do not always hold true for extreme climate events. For example, in 2017, as I mentioned earlier, Hurricane Harvey made landfall along the Texas Gulf Coast as a record-breaking storm for its size and the amount of precipitation that it produced. This extreme precipitation event led to prolonged excessive flooding in the salt marshes, causing sudden widespread mortality of Spartina alterniflora, the dominant marsh grass. When we included the dieback sites into this model, we saw that the dieback occurred at elevations above the wetland collapse threshold. Here, it's occurring where we would normally expect to see healthy marsh. And so we have two important conclusions from these results. Extreme precipitation events can cause flooding that impacts marshes that are normally safe from flooding stress. Second, there is a shift in the flooding threshold, making salt marshes more susceptible to collapse during extreme events compared to normal flooding conditions. And so marshes are more vulnerable to extreme events, and we need to account for these drivers in addition to sea level rise in vulnerability assessments. Furthermore, identifying elevation thresholds for vegetation transitions provides critical data for targeted or desired ecosystems. In this recent study in San Bernard, we quantified the transition from high marsh species, which included graminoids and succulents, to low marsh species. In addition to identifying these zonal boundaries, we also quantified the optimal elevation ranges for peak plant performance. And so this is an area where there still remains uncertainty in both marsh collapse threshold and optimal elevation of plant performance for multiple habitat types across the northern Gulf of Mexico. Okay, so how can this information be used for site selection? The key here is linking these elevation thresholds to the landscape by combining both on-the-ground field data and remotely sensed data in these analyses. Linking the elevation thresholds to land cover data can allow us to identify wetland vulnerability at a larger scale and also provide us with the important information of where wetlands are vulnerable. This helps managers to identify site priority for restoration efforts. In another study along the Texas Gulf Coast and McFadden National Wildlife Refuge, we quantified the elevation threshold for marsh collapse in a brackish Spartina patens marsh. And so in addition to declining plant cover, we also saw a significant change in the spatial configuration of the marsh, with increasing fragmentation as elevation declined. In this case, we were able to identify thresholds for both the local and landscape scale indicators of marsh loss that can be used for vulnerability assessments at the larger scale. And so to accomplish this at a regional or national scale, we need more spatially explicit data that we can link to these threshold relationships. We need better high-resolution maps of wetland habitat zones along with their elevation. Current research by Nicholas Enright at WARC is working to provide maps of high marsh and salt pan flat habitats across the northern Gulf of Mexico. And similarly, it's critical to incorporate future scenarios of climate change, such as sea level rise, as well as land use in these spatial analyses. Another great example of this is work by Nicholas Enright and also Mike Osland and others, who are working to identify barriers and opportunities for marsh migration. And I believe Mike will be speaking about this in more detail as well. And so ideally projecting wetland cover into the future under multiple scenarios of sea level rise and flooding can be paired with these ecological thresholds to identify areas in the greatest need of restoration. And that's all I have for now, and I'll be happy to take questions and have discussion after the other presentations. Thank you.
All right, so that was Camille. I forgot to introduce her presentation, but thank you, Camille, for that. I don't see any questions in the chat, but let me just, oh, here we go. So Judy asked, what is the hollow vegetation type? So Camille, do you mind addressing that?
Sure. Thank you, Judy. The hollow vegetation is representative of that more fragmented landscape, so configuration. in this type of wetland, in a Spartina patens dominated wetland, what happens is they will start growing in hummocks or clumps, and which are associated with hollows, areas of lower elevation that are often flooded for long periods of time. And so the hummock and hollow formation represents that fragmented landscape configuration.
Thank you.
Thanks.
Great, thanks, Camille. Okay, so I'm just checking comments. All right, one more, Camille, and then we'll move on. Do you also have how the rest of the landscape might change with regards to mapping the wetlands for landscape forecasting?
Yeah, I think that'll be extremely important because where, the other categories, of land cover, those are places where wetlands may or may not migrate into. Those could be barriers or opportunities for migration. Again, I think Mike might be talking about that in more detail, but yeah, when we start forecasting land cover change, we have to look at all the different land cover types because there will be transitions in and out of all of those land covers.
Perfect, thank you. All right, Breck, if you're ready, let's go ahead and roll up Neil's presentation and we'll jump right into that.
Hi, so I will be talking about salt marshes along the coast of the United States, which are primarily geomorphic features with a strong biological component or biological features with a strong geomorphic component, depending on who you are. There's about 16,000 square kilometers of salt marsh in the USA, which is actually quite a bit if you think about the width of a tidal shoreline. It's actually about 100 meters width across the entire US tidal shoreline on average. And what salt marshes provide are valuable habitat for several threatened and endangered species, carbon stocks, and debatably sequestration, and also coastal protection for areas that are just behind them. The current vulnerabilities of salt marshes are to external forcing such as sea level rise, waves, erosion, and storms, as well as sediment deficits, which are causing widespread marsh loss across the United States and the globe. Ultimately, though, marsh loss is a biogeomorphic process between these coupled forces of ecology with the plants, as well as sediment transport and hydrodynamics. And importantly, you have to think about marsh loss in a three-dimensional context. So this plot on top is showing sort of the historical concept where marshes just respond to the vertical forces of tides and accretion and biomass production. But in fact, when you look at real examples from the world, you see this three-dimensionality where you have interior ponding, you have widening of channels, and you have edge erosion. When you think about sediment budgets and salt marshes, a lot of work has been done on looking at the budget for salt marsh. So if you think about withdrawals of sediment in red here and deposits of sediment in black, and then the net supply that may come in and out, you can come up with a sediment budget for a wetland. And numerous studies, this is actually a modeling study done over a very wide parameter space, shows that marshes are almost never in equilibrium. They're almost always either expanding in response to increased sediment supply and low sea level rise, or they're eroding in response to reduced sediment supply and increased sea level rise. To be clear, most of the marshes in the US fall down in this area. Sea level rise, between 3 and 10 millimeters per year, and sediment supply well under 200 milligrams per liter, which is in this area here. So given that, there's a lot of restoration going on to counter marsh loss across the country and the world. Most of these actions that you see listed here on the left are aimed to either increase elevation by adding sediment, restore the hydrologic connectivity either through remediation of ditches and ponds or removing barriers, or by improving the stability of the wetland through shoreline protection or planting. And then the outlier here is migration corridors, so finding areas where marshes might naturally transgress into forest. So where do we fit in? So over the last 10 years, our group has been measuring sediment budgets at marshes across the country. So these are what we would call process-based measurements. And one of our first studies showed that you could compare the net sediment budget, which is here on the y-axis, with an aerial image that pulls out a metric called the UVVR. So this is simply the ratio of unvegetated areas to vegetated areas across that control volume of the marsh. And what we found was that, that there's this very strong correlation, but that all the sites were also in deficit, which was interesting. And on the bottom here, you can see what those control areas look like with marsh in the orangish colors and water in the bluer blue or black color. So this is a marsh with a UVVR of about 0.1, 0.4, and 1. And the idea is as a marsh degrades in response to sea level rise, sediment deficits, invasive species, whatever, that loss of marsh plain leads to a net export of sediment and then runaway expansion. So with these process-based measurements of sediment fluxes that we made, we're able to link them with a geospatial metric that can be more widely applied. So then with the help of Brady Couvion at work and others, we developed a 30-meter resolution UVVR for the entire United States just last year. So this covers the contiguous United States. It's annual data from 24 to 2018, and then we composite those for a 5-year average along with the standard deviation amongst those 5 years at every pixel. So what can we do with this? The first thing we tried was using that threshold that you saw in the prior plot of about 0.1, and in this case it's 0.15 based on some other studies that have been done. And the idea is that below a UVVR of 0.15, you have a stable marsh pixel or stable marsh parcel, and above a UVVR of 0.15, you have an unstable parcel. So we use this threshold that you can see here, and each one of these dots represents a pixel across this marsh area in North Carolina. So in this bottom box here, we are showing wetland pixels that have a low UVVR and also have a very low standard deviation of the UVVR, which is here on the y-axis. So this is this dark green box. And then over here you have wetlands that have a high UVVR but are consistently in that high without a lot of variation. And these are the two most interesting areas. And you can see them mapped onto this landscape. And so what we're showing here is that anything in dark green is basically a stable area that doesn't need intervention, and we're pretty certain that it's stable. However, the dark pink areas, we're certain that they're unstable because they're consistently above that threshold. And then the light pink are actually areas that are both unstable and have very large fluctuations. And these actually represent managed impoundments. So these are areas that are periodically flooded and are typically well above that threshold. So we've used this geospatial metric now to give a snapshot of stability as well as certainty in that stability. The other thing we can do is combine the UVVR with high quality elevation data from LiDAR. And what we do is a very simple decision matrix, again using that threshold of 0.15 for the UVVR, and then an elevation threshold relative to mean sea level. And these are 4 boxes showing 4 options of that elevation versus that UVVR. So up here you have marshes that are high elevation and low UVVR. So these are both intact laterally and vertically stable. This would be a parcel that you might want to protect. It's adjacent to a forest. There's a good opportunity for marsh migration here. However, on the bottom right here, you have a marsh parcel that's low elevation and falling apart. This might be one that is not useful for restoration because it might be too expensive or just not worth it. And then there's obviously these other 2 options that are equally interesting. But what's beautiful about this is being able to map those decisions across the landscape and easily point out areas that might be ripe for restoration or ripe for abandonment. Lastly, we developed another method that integrates elevation, UVVR, and sea level rise into a metric that we call the lifespan. And it's basically it takes the amount of sediment within a marsh parcel and then divides that roughly by the sea level rise rate to give you a time scale that you have before that marsh parcel has to cannibalize the sediment in the marsh plain in order to maintain its elevation. And the really nice thing about this is it gives a very simple tool and number that landholders, stakeholders can use to message the expected lifespan of restoration action. So for example, in Assateague National Seashore, we have marshes on the north side that are ditched, and we have marshes on the south side that are not ditched. And there's a drastic difference in lifespan. So up here, these marshes have lifespans of less than 100 years, and here they have lifespans of more than 100 years. So the stakeholders can communicate what restoration might gain them in terms of lifespan. If we remediate these ditches and open ponds, we could potentially gain hundreds of years of lifespan out of these important geomorphic features. And lastly, on the note of combining these geospatial metrics with process-based models, I'm showing an example here from our St. Petersburg group, Karim Alizad, Davina, and others. And this is the hydromem model. So this is basically a tidal hydrodynamic model merged with an explicit biomass model for marshes. And obviously it can only be run on regional scales, not on a CONUS type scale. But it provides very realistic representation of elevation, tidal dynamics, and how the marsh substrate responds to that inundation. And then the other model, which I showed on the prior slide, is this lifespan model that is not a process-based model. It's a metric that uses high quality geospatial data to come up with a timescale. And what we did with Cream and Davina is we combined these two where we have overlapping data in Plum Island under 3 different sea level rise scenarios. And what you can see a very clear relationship between lifespan and the vulnerability index. And what the value of this is that you can provide both to a stakeholder and show them both of these methods and show how well they correlate and give them an idea of certainty in which parcels are most resilient and which parcels are the least resilient. So all of this is just to say that I think there's a few broader ideas that might lead us or might inspire us. So our group here in Woods Hole and maybe within our program in coastal marine geology is really great at process-based measurements and models. And in the last few years, I think we're getting better at linking them with geospatial metrics for large-scale land management. And now with all the satellites we have online with UAS capabilities, we have lots of remote sensing-based geospatial metrics that we can apply across landscapes. So the challenge, I think, for us is merging the high-quality measurements and models we make with those geospatial metrics so that we can extrapolate them across large landscapes. And what all of this has taught me in the last couple of years is all the complex things we've done over the years with numerical models, with PCA, with vulnerability analyses. None have been as powerful as these very simple 4-box decision matrices, mapping of stability, and computing lifespan. These are the things that are really resonating with stakeholders. And I thank you for your time.
All right. So Neil, I don't know if you've been able to track the chat, but there's a couple questions there. I wonder if you mind touching on the first one related to vegetation response to flooding characteristics.
Vegetation response, flooding characteristics. Is that Eric? Are you talking about Eric's question?
Eric's question. Sorry.
That was actually for Camille. Sorry.
My mistake. All right.
So, well, but I think Camille and I have the same answer, that the methods to correct LiDAR data for elevation are there, but we need better estimates of on the ground elevation for sure.
Right.
And then Tanya's question, we have done lots of field measurements of erosion and rates of erosion. We have a couple papers showing kind of the universal relationship between wave energy and edge erosion. But the work that I showed here was almost all aerial photography from NAIP or a satellite from Landsat. And then the hydro-mem question would be for Davina. My recollection, Davina, was that doing it for the entire southeastern bight was not computationally possible, correct?
Yeah, so I wrote back in the chat. The hydrodynamic portion of the hydro-mem model, it's a numerical model, and so it's really computationally expensive, and so we can really only look at regional scales. So we'd have to break up CONUS into regions, so maybe doing like a South Atlantic bight, or we've done applications for like the Big Bend region of Florida. So that's kind of the scales that we're looking at.
All right, excellent. So let's keep some of those for the wrap-up discussion at the end as well. And I know, Tanya, you had a comment in there, and Kurt as well. But let's move on to Eric's presentation. And again, please track the chat, especially the presenters, so you might be able to get a preview of some of the questions that are coming up as your presentation is playing. So go ahead, Breck, whenever you're ready.
Pleasure to share our work assessing habitat vulnerability and adaptive management trade-offs for coordinated ecosystem and natural hazards planning. I'm Eric Grossman, a research geologist with the Pacific Coastal Marine Science Center and the lead of the coastal habitats in Puget Sound and Puget Sound Coastal Storm Modeling System projects. This is a collaboration with about 20 scientists from the Western Fisheries Research Center, Washington Water Science Center, Western Geographic Science Center, and the Northwest Pacific Islands region, and my team. And this photo shows one of the few examples of large-scale estuary restoration in Puget Sound down here in the Nisqually Delta, aimed to recover declining abundance of Chinook salmon and shellfish and other wildlife. And it's the treatment of these dikes and levees and roadway infrastructure like the Interstate 5 that are really challenging to address. And so there's a need for tools to determine the extent and location to restore estuary functions like these green polygons here in the Skagit Delta, given the extensive loss of estuarine habitat and competing land use and pending climate effects. And questions also to address include in how to restore estuaries and connectivity, including is full levee removal needed, just notching, breaching, setbacks, and balancing function and protection, understanding the hydraulics in the system. And so there's a real need for integrated science to address cumulative and external effects on restoration outcomes, and to develop more predictive tools to guide expectations of restoration, measure performance, and inform adaptive management beyond the existing guidance that really relies on just simply removing levees and hoping that water and sediment will come. So the need for integrated modeling and research is really exemplified by this image of the last year's Nooksack River flooding. In addition to hazards that affected the interstate and infrastructure, you can imagine the importance of understanding the flow of water and sediment to thousands of acres of habitat restoration, stormwater and sewage releases, contaminants, and in particular, efforts to restore tidal marsh, eelgrass, beach and shellfish habitats, which are identified targets for recovery by the Puget Sound Partnership. This is really important given our projections of a lot more sediment coming down these systems with climate change, and a recent paper showing that land uses up in the floodplains are having adverse impacts to these restoration efforts down below. So there's a real niche for USGS science to inform decision support, habitat migration, extreme events, understand sediment, and especially these compound effects. So we put together an exciting research program through the Coastal Habitats in Puget Sound project, emphasizing the ecosystem services and impacts of sediment. And we've targeted 7 estuaries stratified by gradients and disturbance in order to then extrapolate some of our findings a little bit more broadly. Producing models of sediment budgets and flux to marshes and restoration projects, habitat change and disturbance thresholds, looking at sediment interactions and contaminant effects, and habitat suitability models. And then we've paired this with Cosmos to project coastal storm inundation. And EPA is going to be using this for their National Estuary Program vulnerability assessment criteria, informing project vulnerability, longevity, and prioritization. And eventually, we'll be able to use these flood models and maps of flood duration, depth, duration, velocities, like you see in this image, to also better understand the effects on morphology and habitat change. Taking into account extreme events like the 1-year, 10-year, and 20-year events with sea level rise, which add a whole lot more for planning than just FEMA's base flood elevation, for example. We're taking an approach of pairing predictive models and observations to validate what we're learning of system responses. And so in the next few slides, I'll talk about the modeling, some of the mapping and remote sensing and sampling efforts that are probably more relevant across the regions. But if you're interested in some of the chemistry and effects-based physiological studies we're doing with sampling that we're collecting, please let me know. So this is an example of our modeling to address the vulnerability of this system to insufficient sediment supply and flood hazards, and examine remedies for both through that yellow and green arrow. The first approach with Delft 3D was and observations at these white arrows calculated the flux of sediment to this restored area and found that only 14 to 32% of the fluvial sediment load is reaching the system, and that it would take upwards of 80 years to recover the grade sufficient for marsh growth. And when we looked into the future at flooding with a compound flood modeling, we found that large extreme events like a 25-year stream flood in 1996 are to become a 10-year event in the 2040s, and that the I-5 causeway there exacerbates the flooding on the landward side. And by opening up and connecting historic channels to the top of the delta, we in fact add sediment supply to help the marsh recovery and reduce the flooding. So some of the tools and approaches we're using to inform and validate models include remote sensing of change, including the use of radar, which is great in cloud-covered areas, and applying backscatter intensity differencing among scenes to pull out flood extents, just general inundation, sometimes the processes contributing like rain on snow, and just general land cover and habitat changes. We're also using different types of sonar. This is just an example of repeat mapping of both bathymetry and canopy heights of vegetation to better understand change and what's driving some of the extensive loss in eelgrass environments. We also use camera systems at the reach scale to examine properties like total water levels and wave run-up. But I thought this example of analyzing changes in substrate might be interesting for this group. Looking at the variance in image intensity over that dotted line, we've been able to sort out that the standard deviation over time correlates well with coarse and mixed systems versus more uniform and fine. And then down below, we put together an interesting camera-mounted sediment trap that, again, uses code and examines the image over time, and in this case, looks at the accumulation timing and rate in this clear liner underwater over about a month to determine what in fact is suspending material off the bed and able to resolve wave resuspension versus fluvial inputs. And this is really helpful for then validating our models of the resuspension frequency across systems. We found this camera pretty useful for other things like crab, fish, and other wildlife. So reflecting on tools, approaches, and support that would help to move forward, there's some fundamental data that are needed for these types of integrated models. Bathymetry, substrate, wind speeds over water that are important for waves, and sediment budget that could benefit from USGS institutional support. The understanding of nearshore ecology and sediment interactions with fin and shellfish is important, and we need a lot more expertise and approaches to address these. And while I work very closely with a number of tribes and with what's called the Pacific Marine and Estuarine Fish Habitat Partnership, who are integrating our work towards looking at vulnerability of habitats, we're only scratching the surface with some of these physical models that I've described. And so some kind of extra capacity to engage with these groups would be really helpful. And hopefully what I've described will be somewhat useful for a number of other landscapes that is part of this workshop. Thank you.
All right, excellent. Eric, great presentation. I don't see anything in the chat right now, but my guess is we'll have additional follow-up questions during the wrap-up. So let's go ahead and move on. Breck, Judy's presentation, I believe, is next.
Hello, everyone. My name is Judy Drexler. I'm a wetland ecologist at the California Water Science Center, and today I'm going to be talking about wetland restoration in the Sacramento-San Joaquin Delta, a highly altered landscape increasingly stressed by climate change. The Delta is the landward most part of the San Francisco estuary. I'm going to be talking about that today, and later you'll hear from Karen Thorne about the lower estuary. The Delta is very important. It's a very large agricultural region. It's also a major part of the conveyance of water throughout the state. You can see on the right here many different habitats that we have in the Delta, and we also have our share of invasive species, which I'll be talking about later. I'll start off by talking about the major stressors in California and the Delta. In the Delta, you cannot get away from the legacy of drainage for agriculture. It used to be this massive 2,300 kilometer square tidal freshwater wetland region, and then it was converted 98% to agriculture. You can see on the left image there. And then this led to land surface subsidence because it's essentially what happened was the peat was oxidized to carbon dioxide. Now you have a lot of climate change impacts in the San Francisco estuary, of which the Delta, of course, is a big part. You have sea level rise with the saltwater intrusion and increased flooding, and then you have more extreme conditions and storms. You have a greater percent of precipitation from atmospheric rivers, but you have less storms overall. Of course, you have drought now, but then you also have flooding, and you can have changes in freshwater availability. Particularly now, we have very low snowpack and more rain than snow. We also have some non-climate impacts and stressors. We have endangered pelagic fishes due to the change of the food web after conversion to agriculture, which has led the Delta smelt and several other fishes highly imperiled. We have a lot of invasive species. The whole estuary is one of the most invaded estuaries in the whole world, and we have a lot of invasive aquatic plants, fish and clams, and we have water quality concerns. We have nutrients, and we also have salinity. And a new thing that's happening is there's a heightened salinity, and this is bad if you're exporting water to Southern California. So there's an emergency salinity barrier that was put in. And there's also now this Delta conveyance. It's under a lot of lawsuits, but it could be a tunnel that's put in to move water from one part of the Delta to another. So land use change and intensive farming have essentially resulted in the ecological collapse of the region. And that's why restoration is really the only remedy. And that's why this talk is really focused on that. Restoration of the Delta has a long history, but not a very large amount of restoration has really been done. Now there's a plan and a program called EcoRestore, which was launched in 2015 to restore at least 30,000 acres of critical habitat in the Delta itself and just downstream in Sassoon Marsh, and then also in this Yolo Bypass region, which is a bit to the west. Now, some numbers to consider, though. 30,000 acres sounds like a lot, and it's a great step forward, but it's essentially 5% of the original Delta size. In carbon accumulation, after 100 years, if we use the typical amount of bulk density and of productivity in wetlands in the Delta, you get about 1.4 teragrams in 100 years, which represents a little over 1% of the amount of carbon that was lost. So it's a good step, but it's still, there's a lot more work to be done. Now I'm going to talk about USGS science to support Delta management and restoration under climate change. I just want to make it clear that there's a tremendous amount of work being done in the Delta by academics, by NGOs, by state, local, and federal agencies. So I'm going to be talking about some USGS projects here that, first of all, Cascade 2, a very large project, and Physics to Fish, also a large project. I was involved in Cascade 2, but not Physics to Fish. And then two projects that I've been very closely involved in: invasive aquatic vegetation in the Delta and Delta marsh sustainability with SWIM. The computational assessments of scenarios of change for the Delta ecosystem is a very large project. It had over 30 scientists and 10 disciplines. It's pretty much winding down right now. But its goal was to assess potential impacts on the Delta, so flows, water quality, and the ecosystem itself, of large future climate management and infrastructure changes. It had a really great approach of linking models of climate, watershed, and ecosystem to evaluate potential impacts of these scenarios that were chosen to illustrate what future change could look like. There's projections that are currently available from sea level rise, salinity, water temperature, suspended sediment concentration, marsh sustainability, and then mortality thresholds for sensitive species, and a phytoplankton model. Now, there's also more work being done on the biological components. The physical components are pretty well completed at this point, but it's a really interesting way of trying to show what knobs there are and what happens when they're tweaked one way or another. And this has been very helpful for management. And if you're interested in some of these publications, I've listed the websites right here. Another big USGS project in the Delta is the Physics to Fish project, which is just wrapping up. This project was really about the fact that high quality habitat is created by the interaction of physical processes and the landscape. So you can have many different hydrodynamically distinct zones, and the delta and this neighboring Sassoon Marsh have these different zones. They used the Lagrangian to Eulerian ratio as a guiding metric, and this can be used to design individual projects or consider cumulative impacts of projects. It's essentially the tidal excursion over the channel length, and you can use it to figure out where the habitats are going to be just right for certain sensitive species. For instance, if the LE ratio is much less than 1, you have a diversity of residence times, and you have different gradients within your system that can be very good habitat for example, a sensitive fish. So this is something that is going to be really helpful to managers because they won't expect certain species to thrive in habitats that really aren't good for them, and they can focus on the habitats that will suit them the best. So the invasive aquatic vegetation in the Delta project was focused on how invasive Egeria densa, a submerged aquatic plant, alters sediment transport processes. Essentially what it does is it's a sediment sink that lines the marshes. It hogs all the sediment. It doesn't give the sediment to the marsh where the marsh could use it to build its elevation under sea level rise. It's also a carbon sink, and it's changing sediment transport processes in the channel as well. I don't have time to talk about it. There's several publications that came out of it, but this is a very important thing to consider in restoration because you want to build sustainable marshes, and if this is happening, you really aren't going to have a good of a chance of that marsh being sustainable into the future. The project I'm currently working on is called Delta Marsh Sustainability with the Coastal Wetland Equilibrium Model, or SWEM. Jim Morris, at University of South Carolina, is leading this project, and we're also working with several people from the San Francisco Estuary Institute. This model is a major improvement over our Warmer 1 model, which I did with Kathleen Swanson and Dave Schallhammer as part of the Cascade 2 project. This is incorporating new things such as initialization of sediment cohorts using loss on ignition and bulk density data from cores, so we're not just starting from equilibrium conditions. We also have new parameterizations of below-ground organic matter accumulation and decomposition. We're including episodic sediment pulses, such as atmospheric rivers. And another thing is we're focusing on resilience measures, not just marsh drowning. So we're looking at marsh decline, including time to tipping point before drowning, and also rate of loss of elevation capital. We're also using the model to look at the entire history of peat formation in the Delta to understand wetland formation processes. And that's about all I have time for, and this is not, this is still in preparation, so we'll have a lot more information in the future. I'd like to conclude by talking about some innovative approaches that are really needed in the Delta. Here's a picture of some high flow releases that occurred at the Glen Canyon Dam as part of these experiments at the Grand Canyon on sediment releases. I think we really need to do some whole system experiments in the Delta. We need to reach across silos. We need to work with ag and academia and federal agencies to understand how tweaking knobs can meet management goals. We need to use opportunities such as major atmospheric rivers to study salinity, nutrients, sediment dynamics, and we need to use these opportunities to see if our models, our hydrodynamic models, are really working, if they're really representing the conditions that are found. Another thing we need to do is we need to consider a new paradigm that might be needed to understand climate change impacts. Many of us in ecology classes or hydrology classes learn that there's quote unquote these normal conditions, and then there's a disturbance, and then there's the recovery from the normal conditions. First of all, there's many disturbances going on right now, but what we also have is some situations where it never returns to quote unquote normal. And this has been shown in a really nice paper by Peterson et al. On watersheds in southeastern Australia, where stream flow never returned to what was originally happening in those systems. Instead, it declined in a significant number of watersheds. And so there's plenty of places in the United States that are getting drier and that could be undergoing these same changes. So we really need to open our minds and think about what's really happening in these systems and how some systems might be changed irreparably and what that means for management. And I've run out of time, so I'd love to discuss this more during the workshop. Thank you very much.
All right, great. Thanks, Judy. I don't see anything in the chat right now, but I noted, Eric, you had a question that you responded to. And for those of you in the chat, I appreciate you tagging the speaker or the presenter like you have. That helps us as facilitators as well, make sure we can keep track on who needs what questions addressed. So let's roll into the last presentation of this session from Tanya. And then again, we'll have about 15 minutes or so to wrap up with all 5 presenters to ask some more detailed questions or have a little bit of a discussion. So go ahead, Breck.
Hello, I'll be talking today about environmental monitoring and modeling in the Midwestern landscape. And questions that I get are, how do we know we're making a difference and how long will it take before we see it? And really both of those are focused on this idea of establishing or having a comparison of baseline conditions. So let's start with this idea of where we actually have a temporal baseline, enough data to let us look at, for example, what's the difference in contribution of climate versus management. And what we're looking at here is a 100-year-old forest sitting in the middle of a surface mined landscape. And you can see some different snapshots over here on the left. But we were able to use EGRIT to essentially pull apart the climatic influence from the land management influence. But we rarely have that much data. So what about when we need to instead look forward in terms of reclamation? And so here we're looking again at this Robinson Forest example. We have a control basin and we had 2 different approaches to forest reclamation. One a conventional where they run over stuff a lot and then plant grass, and one where they carefully plant individual trees. And we were able to show that the stream flow was more similar to the control when they planted the trees, and that the landscape was more resilient for drought. And that's similar to what we do in agricultural landscapes when people talk about soil health and not tilling, for example, and increasing the amount of organic matter in their soils. The other thing we know is that the stream size we monitor matters. So for example, starting with Robinson Forest, again on the right, we have 2 large streams, Clemens and Coles, and 2 small streams, Falling Rock and Little Millsey, which are nested within Clemens. And when we look at just the precipitation minus stream flow numbers for our period of record, again about 40 years, we see a general reflection of evapotranspiration in the small streams. But the large streams are clearly losing more water, perhaps to groundwater. And so what we see is that depending on if it's a wet year or a dry year, the ratio between the large and small streams varies over the period of record. When we look at the agricultural landscape now of the Maumee, which is what I'm showing you on the left, we see also the importance of looking at small and large streams. So I've got 3 small streams that are outlined in pink, Black, Platter, and Little Flat Rock, and 3 larger trunk streams, the Maumee River and the Auglaize River at different locations. And the first thing you see is that, stream flow actually decreased during this 2019 year, which was so wet from October on that 30% of the agricultural land actually went fallow. And that also meant less nutrients were applied. But you see stream flow increased at each of the larger sites. When we look at the nutrients, we see that there's quite a bit of noise in there. But one thing to point out is that Black Creek responded differently to this year than Platter and Little Flat Rock. So Black Creek actually went down in terms of total phosphorus and suspended sediment, while the other 2 small streams went up. And what's also interesting as you look at these numbers is that the 3 large streams went down for both TP and suspended sediment, even though some of the headwater streams actually increased. So this tells us that the trunk streams buffer and store material between years, but that the headwaters vary depending on which one you're looking at because they reflect local land management. So to talk a little bit more about the Maumee River Basin, we actually spent a lot of time in Black Creek, which has been highlighted because it's impaired for nitrogen, for phosphorus, and for suspended sediment. And NRCS is putting a lot of effort into getting cover crop implementation in this basin, among other places. And what's great about this basin is that not only are we monitoring the stream gauge in the basin as a whole, but we have an edge of field site shown there in orange in the middle of the basin. And I've shown you some pictures of the edge of field site over on the lower left. Basically, it's monitoring overland flow that comes off of the farmland. And we also monitor the tile systems, which come in each of the fields. We monitor a western field on the west side of the road and an eastern field on the eastern side of the road. And that shows you what that subsurface tile drain network looks like in each of these basins. And really, when we think about this monitoring record, it's only about 6 years at this point, but really, how do we separate climate versus management? If we look at the precipitation record, we've had sequences of wet years, 2017 through 2019, for example, punctuated by periods of dry, 2016, and then both 2020 and 2021. And so that makes it difficult to interpret what we're seeing. In terms of management, we've got multiple sources which are all contributing to what we see in terms of water quality and the amount of water running through the stream. But we also know that stream bank has been identified in a lot of places, and we look at this using sediment fingerprinting. And stream bank is driven by essentially the stream energy. And so here, as in other basins, we've seen that it's a large contributor to suspended sediment. And so that kind of gets us to this concept of legacy sources. So on the left here, we have suspended sediment from a single water year. The blue is telling us that the largest proportional contributor is stream bank, and it's also the largest contributor overall in terms of total load. But when we think about what's in stream bank, we know that it actually carries quite a bit of phosphorus, which means, though it's just shown in the box plot, which means that putting that sediment into the stream is putting legacy phosphorus into the stream. Legacy meaning it's from a previous management year. When we look at the stream bed there on the right, we see that most of the stream bed can also be identified as coming from stream bank until you get to the smallest streams, which are shown up on the top. And so once you start moving stream bed, this is sampled in July, once we start moving that stream bed, we're also moving legacy sources of both sediment and phosphorus. Okay, how do we integrate then these temporal and spatial scales? So this is a quick comparison of event flow and base flow. Base flow concentrations are lower than event concentrations, and also the events at the stream versus the events on the field. And we see that those are actually pretty similar concentrations. But when we look at the particulate phosphorus, where we normalize it for the amount of phosphorus moving, we see that, in fact, the events have a lower particulate phosphorus concentration. And so this has changed how we're kind of designing some new sampling moving forward, because now we can see that we can actually separate out these events in terms of those that are driven by dissolved phosphorus and those that are driven by suspended sediment, because it matters how the sediment is transported to the stream, not just in the stream. So when we look at these events and we separate them based on what's driving the maximum total phosphorus for an event, we look at dissolved phosphorus-driven storms and sediment-driven storms, and that's what I'm showing you here. And what we see is that stream flow matters, exposed fields matters, and soil water storage matters. That basically each of these show a difference between these two types of events. And what's interesting is that most sediment-driven events occur when the fields are exposed, because that combines the soil water storage. So this matters because in this basin, the emerging and the forecasted storm patterns are more frequent, they're larger, and they're wetter springs with drier summers. So this means that this type of event is going to be more common. So finally then, what do we aim for? So I've shown you that there's information that there are drier antecedent conditions, which have lower suspended sediment, lower total phosphorus, higher dissolved phosphorus, and wetter antecedent conditions, which are the flip, basically. And our new sampling strategy is targeting dry versus wet antecedent conditions as we focus on the Fox Basin. And we see that there are two separate populations, not only of suspended sediment, for example, but how the particulate phosphorus is moving with the suspended sediment. Why are these sediment-driven events different? Well, newly eroded stream bank goes directly into the stream. It doesn't have opportunity for enrichment during transport to the channel. But this erosion is driven by water delivery to the channel. So this has something to do with tile drain management, which is ubiquitous in the Midwestern landscape. So that leaves us with some final questions, though. What about stream bed mobilization? And what about how dissolved phosphorus and particulate phosphorus interact as they're moving through the system? So this is where some of our questions are going on right now in our focus of our research. So finally, I'll just say maybe in this environment, we don't have baselines, we just have metrics, and those have been specified by some of the agreements. But moving forward, that's how we are trying to address the harmful algal blooms in the Gulf of Hypoxia. But as we try to answer the question of how long, we can start putting age dates using fallout radionuclides. And as we start moving forward and thinking, what does it look like? Well, that's going to vary from basin to basin. And those small headwater streams are key to us linking management decisions and what we're seeing water quality-wise in the stream. Thank you.
Okay. Thanks, Tanya, and thanks to all the recorded presenters from that first session. So we do have about 15 to 20 minutes. First, I'm not seeing any specific questions in the chat for Tanya, but we do have some time now to kind of open it up for more detailed questions or discussions. So those that presented during that session, if you don't mind, turn your cameras on. And then if there are others that want to ask a very specific question, please raise your hand. And if I don't see any, I do have a couple of things that I noted that I'll bring up, but I want to give others a chance first. If you had any follow-up questions on something that they addressed right after, or if there was anything else. So Tanya, go ahead. I'll let you start.
So I mean, there were a lot of commonalities, but some big ones that I found myself writing notes about were sediment budgets and this kind of, whether it's stream bank or edge, and different methods in which I think that we seem to be trying to keep tabs on it, like where material is coming from, where it's going, and where it ends up sitting. So it's interesting because we have a lot of different temporal, time snapshots depending on which landscape we're in, and how the management might have changed over those time snapshots. But it seems like there's some great opportunity for integration there.
Great, thanks, Tanya. And I might just chime in and add here, I think even on top of what you just mentioned is the potential for more extreme events under climate change. And, we talk about higher highs and lower lows, but also those more extreme storms, which tend to then, increase that sediment transport and opportunities for other types of changes because of those extremes. Nick, go ahead.
Yeah, I'm just going to say, kind of sneaking ahead. I've looked at all the presentations and listened to them. You're going to see that theme of extreme events resonating across quite a few of these presentations. So that's something for us to keep our attention on.
Yep. Eric, go ahead.
Just to add to the extreme events, it seems like we're poised to really help look at the so what's and what to do about all of this. And I think we need to focus in on those land use activities that are potentially going to exacerbate the extreme events. I think it's been overlooked in a lot of locations and around certain issues, but the more we can then address those and find how sort of greener ways help the ecosystem restoration efforts and minimize their extreme impacts might be nice.
Great. Kurt, go ahead.
Thank you, everybody who presented already. Appreciated it. One theme that I was picking up on that I wrote down, Neil, while you were talking is trajectory. I oftentimes talk about that when I talk about wetlands. They're not static. They're always changing, whether it be ecologically or geomorphically or whatever it might be. So that could be a theme that we could think about as we're considering some of the later discussions.
Okay, thanks, Kurt. And I'll note in the chat, Neil mentioned universal proxies for things like sediment and geomorphic change. Karen, go ahead.
Hi, nice talks, everyone. Really interesting stuff. Yeah, I also picked up on extreme events. I think someone said in the chat of how we're going to need to define some of our terms because we're going to use them different. So like Eric's talk, extreme event is too much sediment. In California here, an extreme event would be drought where there's not enough sediment and fresh water. On the east, it would be hurricanes. On the west, it would be some other type of precipitation event. So, but I do think it's a cross-cutting theme, but it's really interesting because I think we're all going to define it really differently depending upon where we work. And then I mentioned early on in the chat with Camille's talk is her idea of like this ecological thresholds or trigger points or whatever people want to call it. There's always kind of a new catchy term for it, but I think that's probably a cross-cutting thing also, especially as we keep hearing people's talks. This idea of, what triggers change in in a landscape within a changing climate. So there's some, of course, literature out there, but I think that's something that would be cross-cutting across all the large landscapes also. Nice job, everyone.
Excellent. Thanks, Karen. Mike, go ahead.
Yeah, I just want to put this question out there, and I'll ask it later because I was thinking about the stakeholders who were involved in each of the systems that we just heard about. And just a general question to those who didn't talk about their stakeholders a lot. Some of you did. What are the stakeholder interests that are driving the demand for science? Some of it is obviously a desire to do restoration of the various portions of the environment. Some of it may be due to resource management concerns or driven by resource management issues. Some of it might be infrastructure development or infrastructure maintenance. And then there might be some, maybe this is a subset of some of the previous categories that are being driven by requirements that were put in place by Section 7 or other requirements of the Endangered Species Act. So I just would invite those who didn't already talk about what's driving demand for science in their systems to comment on the composition of their stakeholders.
Tanya, you want to take that first?
I talked a little bit about our stakeholders and the fact that, they think a lot about haves, and they really do. John's been there when we've been in a room and EPA says, well, yeah, but how long is it going to take until we fix this? And on one hand, I know that sediment is painful to measure. We've done, sediment budgets, we've done assessments of erosion, and a couple things like that. But I can tell you that in the landscape where almost all of the management money goes towards agricultural, changing agricultural practices specifically, the idea of being able to show them some examples where stream bank erosion within the stream that, would happen naturally and is going to occur more with more large events, but that is being magnified by the way that water is actually being managed on the field. So not whether or not there's cover on the field, but really how they're working so hard to get the water off the field. Within our smallest cooperator group, within the Black Creek Basin, and also with NRCS, that really started to change the conversation. Here's someone who'd been just, doing everything possible to make sure that people were implementing cover crops and things like this. And it was like watching him go through stages of grief as I had to explain this concept of stream bank. But, now we're talking about 2-stage ditches because that is a way to maybe control some of the water energy. And he could show that to people, so that's part of what's behind it and how those conversations are happening.
Thanks, Tanya. Eric, how about you on the stakeholder side?
Yeah, just a quick example that really gets back to the previous question of thresholds and tipping points and defining tolerance levels. There was a similar type of fish farms and floods big program. And the farmers, echoing what was just said by Tanya, they're very concerned about having to maybe give up lands for restoration of mostly marsh. And what's been happening with some of the actual restoration of marshes is devastating effects downstream to the eelgrass beds. And so folks are discussing, what habitats are more important for, let's say, juvenile Chinook. And it may be that, they're both really important to have at different life history stages. But anyways, the challenge for us with a large stakeholder group, which was engineers, farmers, dike district, drainage district commissioners, all the habitat practitioners and various scientists, was literally figuring out how we could define our sediment flux metrics better to be able to then answer the question, if one or cumulative restorations went on to siphon sediment back to the marsh, build up the grade and get the marsh growing, would we be able to even detect that reduction offshore impacting the eelgrass beds? So there's some really just key, challenging, expensive work, like Tanya just brought up, around sediment, but critical to that, all the stakeholder folks in that program.
Thanks, Eric. Camille. You're muted, Camille. Sorry.
Thanks. I lowered my hand instead of unmuting myself. So in the Northern Gulf of Mexico, stakeholder interests are very much focused on creating wetland habitat to restore, important habitat for species. So basically land creation, and it's focusing a lot on sediment. And this has come up, in all of the talks. Sediment supply, sediment availability is a really important parameter for coastal wetlands, especially to maintain themselves over time. Although it is a difficult thing to measure, and I agree with Neil in wondering if there's a more simple metric that could be used across all of these ecosystems that would represent sediment availability, something that we could use to broaden the scale of that assessment of that critical parameter. I think elevation in some cases can be used, but maybe that's a question to the group. If sediment supply is a big component to habitat sustainability, what is a simple metric that could be used across these ecosystems?
Great. Thanks, Camille. Judy, go ahead.
Yeah, I was on I studied in the Squally River Delta as well as the Bay Delta, the Sacramento San Joaquin Delta, and fish are really driving a lot of the policy. Endangered fish are really driving the policy, the state and federal agencies, local agencies. It's just an incredible driver of restoration and of really trying to understand processes. Some of us sometimes get frustrated because, at least in the Delta, so much of the work is geared only to fish. And many of us are trying to say, hey, we need to look at the processes. And that's why that Physics to Fish project that I described is so important, because you need to understand the whole process of flows. You need to understand, habitat, which is not only for the fish, it's for many other things. You need to understand what's invaded the habitat, like what I study with the submerged aquatic vegetation and what many other people study. And so it's really trying to get that concept across of ecosystem processes and ecosystem engineering by invasive species, and how that affects habitat. And then of course you have the climate change on top of all of that.
Excellent. Thanks, Judy. Anyone else? We still have a couple minutes before we wrap this session. Let me ask any of the other coordinators, any additional thoughts, questions, comments? Tanya has one more, so go ahead, Tanya.
Well, the other thing I heard a couple different potential applications for was, the photography, that whole sediment thing. That's great, although I suspect our streams are too turbid, but it would be great to check it. But it, depending on who we work with in the survey, there are different machine learning methods to try and make some use out of repeat methods without someone sitting there and doing it, so that we can actually put more data in and maybe have a shorter time step. So I just saw a lot of opportunity for that in several of those talks.
Great, thanks, Tanya. Ken, go ahead.
Hey, thanks, John. Great presentations, everybody. And just one other piece that I fold in, or it's not a surprise, but we saw an awful lot. Almost everybody seemed to mention the historical, current, or forecast land use change as sort of this co-factor that we have to be thinking about broadly along with climate. And so if anything, it was just refreshing to see that everyone's wrestling with that too.
Great, thanks, Ken. Great observation. Okay, so I think that should wrap us for this first session. I'll just say, well done, folks. I think the recording approach works extremely well. It helps everyone kind of stay on track, gives us some flexibility to have some of these discussions. I think we've all been part of those meetings and workshops where the presentations, everybody goes a couple minutes long, and then all of a sudden we don't have time for that discussion. So I'm really happy with the way this first one turned out. We have about 17 minutes for a break. So please be back promptly or even a couple minutes early, 2:30 Eastern, adjust accordingly. And we will start the next session of presentations that Ken will facilitate. But again, thanks so much. I think it was a great start to our 3 days. And let's go ahead and do what you need to do, get a quick break in, and then we'll come right back and Ken will start us on the next session. So thanks all. We'll see you soon.
Thanks.
Don't
Thank you.
disconnect. Just you keep everything open. Breck will have a slide up and everything like that. But yeah, just go ahead and stay connected. Just mute cameras, whatever, and we'll see you in a few minutes.
Without knowing how many folks are still sitting at their desk with their cameras off, this is Ken. I'll just make an announcement. We've got about 2 more minutes and we'll start our second presentation session. Thanks. Excellent. Thank you, Breck. That's exactly what I was about to ask, was if we could end the sharing and go back to just sort of the display of all the participants. So we'll wait just 1 more minute. We'll let everybody get here, and just to keep us on track, we'll jump right in. So Nick Allman, do you have any as our kind of MC? Did you want to offer any other comments, or are you just ready for me to jump into the second session when we strike 2:30?
I'm ready for you to jump in. It's going great. Thank you.
Excellent. So we're there, and that's a quick introduction comment. So this is working really well. We're staying on track. This is unfolding kind of the way we'd hoped and planned. So we're going to follow the same process as last session: recorded talk, 2 minutes of live question and answer, and then 15 minutes at the end. We're still going to move around and have some coastal flair, but now we're going to incorporate some inland components in the next round of talks, and they're going to be just as high quality as the ones we've seen. And so just as we run through these, I'll encourage presenters, go ahead and watch the chat as your presentation's going, so you can see those questions come in. It'll just keep us moving a little more efficiently. And so with that, our first presentation is Mike Osland and Breck. Thank you very much.
Hello, so my name is Mike Osland, and I'm a research ecologist at the Wetland and Aquatic Research Center in Lafayette, Louisiana. And today I'm going to be talking about coastal wetland vulnerability to climate change and sea level rise. All right, so what landscape do I work in? I work primarily in coastal wetlands, and coastal wetlands are diverse. In the United States, we have many different kinds of coastal wetlands, and those wetlands are strongly influenced by climate. And so across most of our coast, we have salt marshes, which are shown in panel C. Those are graminoid dominated wetlands, and those occur where it's cold, wet, and saline. We also have mangrove forests. Those are especially abundant in South Florida, and those occur where it's hot, wet, and saline. Now, along our more arid and salty coasts, where it's hot, dry, and hypersaline, we have the coastal wetlands shown in A and B. And so those are algal mats. Those tend to be common where it's very hypersaline, too salty for plants. Or B, those are succulent dominated salt marshes. So mangrove forests are most common in Florida, but they're also present in Louisiana and Texas. Salt marshes are common across much of the country, and the succulent and algal mat dominated coastal wetlands are most common in South and Central Texas and California. All right, so coastal wetlands are vulnerable to a lot of different aspects of climate change, and that's due to their position at the land-ocean interface. And so they're vulnerable to accelerated sea level rise. That's the aspect of climate change that has the potential to have the most impact on coastal wetlands. And there's a figure here that shows sea level rise scenarios from the most recent interagency sea level rise report, Sweet et al. 2022. But beyond just sea level rise, coastal wetlands are also vulnerable to different aspects of climate change. Warm winters can lead to mangrove range expansion at the expense of salt marsh. Precipitation changes, specifically drought and flooding extremes, can lead to many different kinds of effects on coastal wetlands. Hurricane intensification affects coastal wetlands along the Gulf and Atlantic coasts. And then lastly, coastal wetlands are vulnerable to interactions between many different climate and land use drivers. So why is this work important? So coastal wetlands provide many ecosystem goods and services. They're frequently ranked among the most valuable ecosystems on the planet due to these many ecosystem goods and services that they provide. Okay, so since this is a national working group, I'm going to try to highlight products that span large areas. And so in terms of sea level rise, there are two primary mechanisms that allow coastal wetlands to adapt to sea level rise. So even though coastal wetlands are highly vulnerable to sea level rise, they're also highly resilient. They do have mechanisms to adapt. The first mechanism is adaptation via vertical movement, and that's due to feedbacks between inundation, plant growth, and sedimentation that actually lead to elevation gains that can enable wetlands to keep pace with moderate rates of sea level rise. Now note that I said moderate rates of sea level rise. The second mechanism is adaptation via horizontal movement. And so some other words for that are landward migration or transgression. And that's the movement of coastal wetlands upslope or upriver into adjacent ecosystems. So a group of USGS scientists recently finished a national effort to address this question: where can wetland landward migration occur? And so here's one figure from that paper. It's recently been accepted to Science Advances, and this is a figure that shows the potential for wetland migration in area, kilometers squared, for all of the coastal states along the Pacific, Gulf of Mexico, and Atlantic coasts. And there's three different categories shown here. The black is potential tidal saline wetland migration into freshwater wetlands. The hatched area is potential tidal saline wetland migration into uplands. And the gray area is potential freshwater wetland migration into uplands. And so there's been an intense debate within the wetland community regarding wetland migration and the potential for wetland migration to offset seaward wetland losses. This is the first study to characterize the ecosystems that are adjacent to wetlands, the ecosystems where wetlands are moving into. And the take-home message here is that 2/3 of that wetland migration occurs into freshwater wetlands, and only 1/3 is into uplands. And so a lot of that wetland migration is not really a wetland gain. It's one kind of wetland replacing a different kind of wetland. Beyond just sea level rise, a portion of my work is focused on climate, specifically temperature and rainfall change. And so it's focused on quantifying thresholds and relationships that characterize the influence of temperature and rainfall on these different kinds of coastal wetlands. And so a very large portion is focused on the influence of temperature on the mangrove to graminoid conversion. And then another portion is focused on the influence of aridity, rainfall, and salinity on the formation of algal mats and succulent plant-dominated wetlands. So within this general theme, we recently produced a CONUS level analysis of coastal wetlands. And so what we did is we divided the country into these 12 biogeographic regions, which you can see in panel A. And then within those regions, we characterized the different foundation plant species that are dominant. And then in B, we show the dominance according to 4 different groups. So the yellow is succulent, plant dominated, the black is unvegetated, the red is mangrove, and the blue is graminoid. And then on the bottom, we have the 2 key climatic drivers that govern these patterns. So we have minimum air temperature, which is a reflection of extreme events, extreme freeze events, and those extreme freeze events govern the northern limit of mangrove. So they govern that mangrove marsh transition zone. And then aridity, which governs the development of the succulent plants and unvegetated wetlands. So we've done a lot more work on this theme. This is just one figure, but I wanted to include it just because it provides a national perspective on this topic.
So I've included this slide. It moves beyond just coastal wetlands, but another portion of my work is focused on tropicalization. And so this figure is from a review paper in Global Change Biology on that focused on the tropicalization of temperate ecosystems in North America. And what this figure shows is that tropical temperate transition, which is found where the blue meets those warm colors. And so this map here is of minimum temperatures from -4 degrees C to less than -20 degrees C. And in that tropical temperate transition, there's a lot of tropical cold sensitive species whose northern range limits are governed by extreme freeze events. So these are extreme freeze events that don't occur every year. They may occur once every 20 or 30 years. And when they do occur, they cause damage or even landscape scale mortality. And so I got started working on this topic with mangroves, but it grew and eventually developed into this review paper that incorporates many different types of organisms. There's a section on amphibians and reptiles and manatees, terrestrial plants, insects, and so on and so forth. And so this figure shows some of those species in these photos. But the general idea is, or the general take-home message is that these extreme cold events, these extreme freeze events, govern the range limits of a lot of different species in this transition zone. And with warming temperatures, some of these species will be able to move northward, which will impact the temperate ecosystems that are currently found to the north. The final request in the instructions was to think about what tools are needed. I think there's tremendous value in coordinated regional networks. And so I've seen this specifically with the tropicalization question, the value of scientists across an entire region working together, collecting consistent information, especially when there's been an extreme event. For coastal wetlands, there's a need for strategic satellite-based detection of regime shifts, specifically for wetland loss and transformation, landward migration, range expansion, and vegetation dieback. And then there's a need for data and tools related to landward migration.
All right, thanks very much, Mike. Great overview. I'm looking at the chat and I don't see any comments in there. Let's see if there's any hands up. Doesn't look like it at this point. One of the other coordinators tell me if I'm missing that, but it doesn't look like we have any hands up. So thank you, Mike. So we'll go ahead, we'll keep rolling because we're really essentially right on time. So now things are about to get a little bit drier. So John Bradford is going to talk to us about some of the Southwest Desert work. So John.
Hi, I'm John Bradford. I'm with the Southwest Biological Science Center, and I'm going to talk to you about some of our work understanding climate vulnerability of dryland ecosystems broadly and the Southwest deserts and their habitats more specifically. This is really a team effort. Mike Dunaway, Seth Munson, and Sasha Reed, who you will hear from later today, I think, are all really integral parts of this team. And what I'm going to try to do in this first talk is introduce you to the prevalence and importance of dryland ecosystems and then provide you some perspectives on what we're expecting in terms of future changes in these systems and what those mean for resource management and some particular challenges that we expect are coming for resource management. And in the second talk that Sasha is going to present later, she'll dig into some of the details about our work with observational and manipulative experiments to try to understand the systems and develop adaptive solutions for the 21st century. So the first thing to know about these dryland ecosystems is that they're very prevalent across public lands management. So most of the land management occurs actually in dryland ecosystems. The map on the left there shows land holdings or land jurisdictions for federal lands, state lands, and tribal lands. You can see in those 11 western states that are highlighted in the outline, there's a huge proportion of the federal land management occurs in those areas. And the right map highlights the fact that these are also dry places. With the red areas are the most arid and then the green areas are the most humid. You can see that a lot of the public lands management occurs in dryland water-limited ecosystems. And that water limitation is worth noting just for a second because it provides some perspectives on what the future is holding. These are drylands. By definitions, they're water limited. As a result, relatively small differences in water availability and soil conditions can create huge differences in ecosystem structure and function. This picture from southern Utah shows a gradient from blackbrush on the bottom there all the way up to alpine tundra over a relatively short geographic distance, because changes in soil and changes in elevation drive sufficient shifts in soil moisture patterns that it really influences the ecosystem structure and function. These are very variable places. So bottom line is, understanding the future of these dryland ecosystems means understanding the future of moisture availability in the context of climate change. And it's worth noting that these dryland ecosystems also have a lot of ecological processes that are directly linked to drought and climate change that are also integral to sort of informing stakeholder decisions. So the top row there shows some of the ecological processes: invasive species, plant mortality, ecosystems being transformed, habitat patterns, wildfire dynamics. These are all drought-dependent, climate-influenced processes that have a direct nexus to a whole suite of specific resource manager and stakeholder decisions, from restoration and rehabilitation, resource extraction. Grazing is very prevalent across drylands. Visitation and recreation are increasing tremendously as population increases and people come from all over the world to recreate in these dryland ecosystems. Of course, wildlife management is an enduring resource management decision. And lately, conservation planning and long-term climate adaptation planning is a growing concern among many resource managers. So the icons that I've shown there, just for some of the federal resource management agencies, highlight some of the examples where just our small group is working with various federal agencies to really get a handle on some of these drought-related processes and what they mean for specific decisions. And the biggest picture, one of the biggest picture I want you to take away from all this today, is that these dryland ecosystems are not only widespread and important, but they're being transformed already. So the top picture there shows a dry forest that is being transformed due to a wildfire, which historically would have come back to forest, but lately is coming back. A lot of these sites are coming back less and less because dry conditions prevent sort of establishment of the trees. That whole hillside was forested with ponderosa pine at one time. This is a site just outside of Flagstaff here in the southwest. The bottom panel shows a similar process with wildfire combining with invasive species to transform a sagebrush shrubland into an invaded annual grass state that really undermines its habitat quality and its sort of the delivery of ecosystem services from these sites. So these transformations are happening, and there's a lot of reasons to think that they're going to get worse in the future as a result of climate change. So I'm going to spend a little bit of time showing you some of the perspectives that we bring in terms of thinking about what climate change is going to mean for these systems. And it starts with just developing a pretty straightforward understanding of where we're headed with respect to both climate and drought patterns. I'll illustrate this using some results for Wapatki National Monument, which is a Park Service site just outside of Flagstaff, down where I live. What I'm showing here on the top panel is sort of a classical climate diagram. You've probably seen these before. They've got months across the bottom. We have mean monthly conditions for temperature in red, relating to the left axis, precipitation in blue, relating to the right axis. The darkest lines in each color show the historical monthly patterns of temperature and precipitation. So you can kind of see what it used to be in the past. And then the shaded areas in increasingly lighter colors for both red and blue show the range among climate models for where the expectations are in the middle and the end of the 21st century, respectively. So lighter colors are further out. You can see temperatures increasing consistently throughout the year, and it is quite consistent across models. All the models suggest increases that are somewhat increasing in temperature in the middle of the century and then greater increases in the end of the century. Precipitation, by contrast, is really uncertain. Some models suggest increases, some suggest decreases, and this uncertainty is especially true in the monsoon season here, which is really critical for a lot of the ecosystems and plant communities of these southwest deserts. So what this means is that we have a situation where resource managers know that their systems are dependent on moisture availability, but the trajectories of future moisture are really unclear. So part of what we try to do is translate this information into perspectives of soil moisture, which I'm showing on the bottom. Soil water potential with wet conditions at the top and dry conditions at the bottom. The black line is historical, or labeled here current conditions, shows wet conditions in the winter, and then the spring comes in, the soils dry down, and then they're pretty dry throughout the summer, and then they wet up again in the fall. The mustard and purple colors show the middle and the end of the 21st century, again with the spread among models among that shading. And you can see there's some pretty clear patterns that have substantial ecological implications. Among them is sort of overall drier soils for this part of the Southwest, and an earlier spring dry down that leads to a longer and hotter dry season that are likely to have pretty substantial impacts on ecosystems. So this is one site. These patterns are not unique to the site, but we also try to apply these concepts to understand the changes we're expecting with respect to climate and drought more broadly across the West. And this is what I'm showing here, some metrics that focus on this question, this dynamic of a longer dry season. So we have two different drought metrics here. The left one is total number of dry days in the near surface soil. So how many dry days do those soils have? And the second one on the right is the longest contiguous dry period in the bottom soils, which is really where moisture is typically more reliable and more stable in these systems. For both panels, we're showing increasing moisture or decreasing dry days in green and decreasing moisture, so increasing drought stress in brown. And the cross-hatching shows places where more than 90% of the climate models agree in the direction of change. So you can get a feel from both of these metrics about some of the geographic patterns in expected drought conditions in the future, with some places getting wetter, some places getting drier. Especially parts of the Southwest are likely to experience increasing dryness and increasing aridity in coming decades. And this is going to have substantial implications for ecosystems and represent a real challenge for resource management. Of course, these are perspectives on sort of general drought conditions. We can also focus more specifically on extreme events. In particular, the occurrence of hot, dry conditions that cause stress. So this is sort of thinking about not only are we going to have longer dry seasons, but when soils are dry, we're going to have hotter temperatures. So we can quantify this by identifying the temperature of the 10 hottest days when the entire soil profile is extremely dry and mapping that across these western drylands. You can see it's increasing everywhere, but it's actually increasing most rapidly in the northern part of dryland regions, where our sort of overall predictions suggest potential for increasing moisture, but this suggests that in terms of extreme events, those areas may have greater increases than other places. And these hot, dry events, we know, have a big influence on driving mortality. This is a juniper mortality event, a photo taken from a juniper mortality event just outside of Flagstaff, just taken last year. Really widespread mortality of these juniper trees that were really thought to be quite drought resilient. This highlights that we're going to expect and should anticipate more extreme events that drive mortality events and essentially create a disturbance from which these systems need to recover. And this is also in combination with increasing wildfire frequency. So there's a lot of evidence to think that these systems are going to be more frequently disturbed, and we're going to need effective solutions for restoration. However, there's also reasons to think that with climate change, the challenge of getting plants to establish to enable successful restoration is likely to get more difficult in the future. As we have a longer dry season and hotter conditions, the probability of a seed in a dryland environment being able to survive in that first year and develop a root system and become established may very well go down. We have a lot of active work looking at this right now and trying to understand what we can do to promote plant recovery and plant establishment in these dry environments. When conditions are bad, even active seeding, this photo is a BLM restoration site where they did quite active seeding and the conditions were not good, and it was over large parts of this project not very successful. And this highlights some of the challenges of trying to restore these dry environments where it's been challenging in the past and is likely to get more challenging in the future as we have hotter temperatures and longer dry seasons. So it's this restoration challenge that's become a big focus of a lot of our work in these Southwest deserts. So I just want to end with a few reminders of the big pictures. Drylands, and especially the Southwest deserts, these are widespread and they're central to the DOI land management. These ecosystems are already being transformed and they are vulnerable to future changes. I think restoration and revegetation are particularly important challenges both now, and they're likely to get more challenging in the future, but we have to figure out how to do this if we're going to sustain these systems in the 21st century. Thank you.
Thanks so much, John. Great overview, and you've been working to address the chat questions, but since we have 2 minutes, I wonder if you want to say something for maybe some folks who hadn't seen the chat about trying to have some soil moisture estimates in the future with less certainty.
Yeah, thanks. So there was a question about, how do we have any reliable insight about soil moisture if precipitation itself is uncertain? And, one short answer to that is that soil moisture is influenced by temperature as well as vegetation activity in addition to precipitation. So if we combine all that together and try to get some sort of mechanistic approaches to understanding water balance, we can get, I think, some reasonable perspectives on how ecological drought patterns of soil moisture are going to change under future climate regimes. Let's see, what else? Any other new questions in there that I'm missing?
Let's see. Mike dropped one in about the stakeholder rundown and any fish and wildlife requirements.
Yeah, so that's a good question. And there's a lot going on, as you can imagine. These transformations that I mentioned are having a big impact on habitat quality, habitat distribution. So there's, I think, a lot of opportunities to really engage with Fish and Wildlife Service. We have some of those sorts of engagement going on right now. It's sort of ad hoc based on kind of individual relationships. We have a lot of work focused on habitat patterns across the broad sagebrush biome, and the Fish and Wildlife Service in that part of the world is working on a biome-wide landscape conservation design effort, and we're helping them think through the implications of climate change for that system. And I think those same kind of broad landscape scale perspectives are likely to grow in the future. And I think our perspectives about both what climate change is going to mean in terms of the impacts on the vegetation, and perhaps even more relevant, like what can we do about it? How can we effectively restore these systems to provide habitat in the future? Those are things we're still working on.
Excellent, thank you. And a number of comments related to this idea of how extreme events, both extreme temperature changes, reducing or setting northern limits for certain organisms, as well as changing hydrologic dynamics in the Southwest deserts are, kind of common themes that we're seeing here. And then since we're right on schedule, before we go back, Mike, I owe you an apology in that it looks like I missed a comment right as we wrapped up your presentation. So folks are getting right back into that. So real quick, Mike, did you want to talk about any of the hydrologic effects? You sort of focused on maybe the temperatures, but there's a relationship as well in some of your systems to the flow side, right?
Yeah, I'll be quick. And that's especially relevant in Texas. So Texas has a precipitation gradient, and along that precipitation gradient, salinities increase in coastal wetlands, and there's also a freshwater inflow gradient. So less precipitation means less freshwater inflow to the wetlands, which results in hypersaline conditions, which produces transitions in coastal wetlands that are a lot like what John is talking about in the terrestrial systems.
Fantastic, a great connection, and I know we see some of that in Chesapeake as well. So thank you both. So we'll go ahead, we'll keep rolling. Our third speaker is going to be Owen McKenna.
Thank you for the opportunity to share some of my perspectives and some of the research that we're doing here in the Prairie Pothole region and as an extension of the Platte River priority ecosystem. My name is Owen McKenna, and I'm a research ecologist with the Northern Prairie Wildlife Research Center. And as of last week, I'm also on a new detail visiting as a visiting scientist with the Midwest CASC. So I want to bring you now to the middle of the North American continent, which is an extremely interesting place to conduct ecosystem science. The retreat of the glaciers left a very complex landscape that supports a large variety of non-human species and is extremely valuable to humans, especially in terms of the migratory waterfowl habitat and agricultural production that happens on these lands. So managing wetlands amidst that agricultural intensification, coupled with extreme temperature and precipitation patterns associated with climate change, it's pretty complicated. And wetlands are critical green infrastructure, and it's known that targeted restoration of wetlands is essential for enhancing both water quality and for migratory bird habitat. Wetlands are indeed fascinating systems to study. They provide a suite of ecosystem services that connect the landscape beyond their sometimes limited spatial extent. Two of these landscape connecting services that wetlands provide are migratory bird habitat and processing and storing nutrients that enhance downstream water quality. Migratory birds move across the landscape and use wetlands in different regions throughout their life cycle. Similarly, stream networks connect large watersheds across thousands of miles. I'll try to give examples of how we are studying these systems at different scales and with different tools and approaches. And you'll hear more details and nuance about the migratory bird story later in this session from Mike Anto. So, as I introduced in my first slide, mid-continent wetland ecosystems are extremely vulnerable to changes in both climate and land use. Luckily, we've been able to monitor and study prairie pothole wetlands at local scales continuously for about 50 years through both wet and dry periods. And we've learned a lot about how these ecosystems function, all while wetlands and grasslands that surround them have been impacted by land cover and hydrological engineering to maximize agricultural yields. The approach that my team and collaborators use to study these complex systems involve fusing empirical ecosystem monitoring with mechanistic modeling and bringing that mechanistic understanding to the landscape using geospatial and statistical approaches. And all of this is to support science-informed conservation planning. So it's a very multidisciplinary effort, and we have a lot of different experts that we bring in to these teams to study these systems. So one landscape scale application of this approach was using our mechanistic wetland hydrology model named Phyllis that was developed up here in North Dakota at the Cottonwood Lake Study Area, coupled with statistical models and future climate projections to estimate the potential impact of climate change on the number of wetlands that are ponded during the month of May. Ponded wetlands in the month of May are extremely important because that's when migratory birds, water birds, are up here breeding. We found a limited shift in the density distribution of May ponds for future climates. And a lot of this uncertainty is driven by climate model uncertainty in changes in precipitation. So climate models are much more in agreement on the directionality of changes in temperature. Things are getting much hotter, but less in agreement on the directionality and magnitude of changes in precipitation. So that relates across going northwest to southeast into this change in variability as you go by, and you can see when you look at all the potential climate futures, there's a big spread in terms of increases to decreases for percent change in those May ponds. With a potential, we found a potential 5% increase to a 30% decrease in wetlands ponded in the month of May. Moving from North Dakota and a much larger landscape level back down to the local scale in Minnesota, we're also working with managers at the waterfowl production area level. And this is embedded within a landscape, as you can see at the top here, where on the left, you can see a much more grassland landscape with smaller basins, wetland basins embedded in the green and blue polygons. And on the right, which is just adjacent to that parcel of land, you can see a much more highly engineered and intense agricultural area where the wetlands are consolidated into larger water bodies and connected to the stream networks more directly. And so with this study, we're trying to understand how do we compare spatially implicit hydrology model data that we can validate using empirical field monitoring versus spatially explicit remotely sensed data. And so it's really interesting at this kind of small wetland basin level to try to R&D test out how remote sensing is doing in terms of mapping surface water compared to our hydrology models. The WPA from that last slide is right here in the black. And so you zoom out a little bit more, and you can see that the landscape gets even more complicated and complex. And so within the Minnesota River Basin, we're also trying to figure out and help managers figure out sort of ways to approach this uncertainty in their decision-making processes, and how to continue to plan for the future as climate change is more and more extreme. And additionally, we're working with U.S. Fish and Wildlife Service HAPIT office to validate our wetland hydrology model with long-term aerial image survey data from the Forest Square Mile survey, and scaling up that from these validation sites across all the states of the U.S. Prairie Pothole region to this wetland management district scale estimate of wetland hydrology that we can relate using statistical models to duck pair estimates. And so we can use that same approach from the Maine Pond study to now move from just physical hydrology type variables and relate climate to hydrology and now into the biology world. So I think frameworks like ecosystem services and natural capital are needed to better assist conservation agencies prioritize and plan for future climate change, and climate change that's already occurring, frankly. I also think that there is a lot of work needed to incorporate the cultural value of these wetland ecosystems that our tribal partners can help us better understand, especially as we move from different regions throughout the U.S. And so thank you to my collaborators and partners in funding agencies, especially the CASCs and Climate R&D and the Ecosystems Mission Area. As you can see from this slide, these are really messy, complex problems with lots of stakeholders, and it needs a lot of different scientific minds and minds in general to tackle these things and come up with interesting solutions. So thanks, and thanks for the invite to participate in this really cool workshop.
Great, thank you, Owen, very much. So I think it's a question, Mike Anto, you had a comment about Fish and Wildlife purchasing lands, particularly for waterfowl production areas. Do you want to speak to that?
Oh, that was just a clarification. Owen was referring to waterfowl production areas, and I figured that a lot of people on this call probably didn't understand what those were.
Gotcha. Thank you. Yeah, that's it's fascinating work, and again, seeing how so many of the themes we already have seen work through here, the effects of hydrology, decision support tools. One of the interesting things I like seeing, sort of trying to get to that smaller scale, sort of what's the management scale in some of these areas. Let me see here. Do we have any hands up? Karen makes the observation that migratory waterfowl certainly is an important topic for San Francisco Bay, and it is Chesapeake as well. All right, doesn't look like we have any other hands up. So why don't we just keep going? Davina is next.
So when we think about how the coast evolves, in the short term, we have storms that can reshape the coast within a matter of hours to days. Now, dunes are the first line of defense against storm-induced water levels, and as water levels exceed dune heights, sand is transported through collision, overwash, and inundation processes. Now, beaches typically recover from storms over a period of months to years. Over longer time scales, like decades, sea level rise has the potential to reshape the coast. And when we think about the effects of sea level rise, it's important to recognize that the coast does not behave like a bathtub, meaning that it's not just going to fill up with water, but instead, these higher water levels will allow waves to act further on our shoreline, which not only will increase inundation, but will also lead to increased beach erosion and marsh loss. And so we need to incorporate these dynamic interactions and feedbacks between coastal processes into our sea level rise assessments for a more holistic understanding of what the coast might look like in the future. To do that, we have developed a transdisciplinary project framework under the CREMA project, which stands for Coastal Resource Evaluations for Management Applications. The objective of CREMA is to inform coastal management decision-making. Our project framework starts by using collected data, various climate scenarios, and some initial state of the coast, which act as input to a suite of integrated models that describe hydrodynamics, geomorphology, and ecology. The output from these models helps us to understand changes to inundation, coastal evolution, and habitats. Those outputs get fed into a decision analysis framework, which informs management actions to align with management objectives. We can also plug specific management actions back into our models and rerun the models to look at the potential outcomes. And ultimately, the outcome of this process is improved guidance and strategies for management decision-making. The CREMA framework has been applied to a variety of projects in the Northern Gulf of Mexico, which you can see listed on the right. These projects are funded by different federal agencies, and their focus is on enhancing coastal resilience through restoration while maintaining critical habitats. The Northern Gulf of Mexico is particularly susceptible to coastal hazards like storms and sea level rise due to its low elevation. You can see some of the impacts of storms on the images on the left here. The top was taken in 2001 at Dauphin Island. The middle was after Hurricane Ivan in 2004, which caused extensive overwash. And the bottom was a year later during Hurricane Katrina, which breached the island. The Northern Gulf of Mexico is an ecologically and economically significant area due to its cultural and natural resources, habitats, and tourism. Our projects begin with stakeholder engagement to fully understand the scope and complexity of the problem. We identify natural resource managers, planners, and end users with specific knowledge about the region of interest and the ability to make or influence decisions. Feedback is solicited through a structured decision-making process so that the products are tailored and readily applicable for decision support. You can see an example of this structured decision-making process through the objective hierarchy on the right here. This is for a NOAA-funded project where we were looking at various restoration options in coastal Mississippi and Alabama to mitigate the effects of sea level rise. And so you can see here through our stakeholder engagement, we identified fundamental and means objectives, including maintaining the marsh footprint, preserving cultural resource identity, reducing barrier island erosion, maintaining habitats, and reducing restoration costs. We also identified specific restoration actions for this area that we then used in our integrated modeling approach to assess their potential to mitigate the effects of sea level rise. We've developed various predictive models that we have integrated to capture the interactions and feedbacks between coastal processes to understand how the coast might evolve in the future. We have large-scale hydrodynamic models that capture ocean circulation, including tides, waves, and hurricane storm surge. Regional sediment transport models that describe longshore sediment transport and resulting shoreline change. Localized barrier island evolution models to simulate storm-driven morphologic change, including dune erosion, overwash, and breaching. Marsh evolution models that describe marsh productivity, migration, and conversion to drowned forests, mudflats, or open water. And then habitat response models to capture the response of specific species, such as piping plovers. The output from these models describes the dynamic effects of sea level rise. In the image on the top left, you can see our projected high tide flooding in Apalachicola, Florida, under a high rate of sea level rise by the year 2100. Areas in blue represent the present day high tide flooded areas, and the orange represents areas that are projected to be flooded by high tides in the year 2100 under a high projection of sea level rise. And so you can see here that there is projected to be increased high tide flooding along the barrier islands and the low-lying marsh areas of Apalachicola. As we get changes in the hydrodynamics, that's also going to reshape our barrier islands and beaches. So the animation on the bottom here is showing projected barrier island evolution at Dauphin Island, Alabama, under different sea level rise scenarios. And so what you can see here is as we crank up sea level rise, we are projected to see more erosion of the barrier island and even breaches or channels to be cut through the island under the highest scenario of sea level rise. These changes in the barrier islands will also have feedbacks to our estuarine and marsh areas. So the animation on the top right here is in Grand Bay on the Mississippi and Alabama border. And this is showing projected marsh evolution under sea level rise out to the year 2100. And so what happens here is that as sea level rises, the marsh tries to keep pace, but eventually starts to lose productivity, and by the year 2100 is projected to almost completely be converted to open water. As I mentioned earlier in our project framework, we can also use our models to assess specific restoration strategies. This is an example we did for a NIFWIF funded project at Dauphin Island to look at various restoration actions, again, to enhance coastal resilience to storms and sea level rise while maintaining critical habitats. And so in this example, we looked at various restoration options, one of which was beach and dune nourishment, which you can see in the image on the top right here. And so we actually took that specific restoration action, plugged it into our models, and reran the models to look at how the beach and dune nourishment would change the morphology of the island in terms of island elevations, and also change the habitat coverage of the island using the output from the morphologic models. For this particular project, a decision analysis framework was established to look at trade-offs between different restoration measures and how they align with multiple stakeholder objectives. And so ultimately the outcome here was improved guidance on different restoration actions for Dauphin Island. So to summarize, we know that the coast dynamically responds to changes in sea level. And so we need to develop these integrated modeling approaches for more holistic assessments of future coastal evolution that capture changes in hydrodynamics, barrier island morphology, and marsh evolution and resulting habitat change. We can use stakeholder engagement to help translate science into actionable information, and in particular, decision analysis or structured decision making can help us look at trade-offs between different restoration actions. Thank you.
Thanks, Davina, very much. And so let's see, there's a question. Mike asked a question about the modeling tools covering both coarse and fine material, particularly the fine, some of that was coming out of the riverine system. Do you want to give a quick summary or a quick answer to Mike?
Sure. Yeah, so we can resolve cohesive and non-cohesive sediment transport, but we're really only focused on the coastal zone and the sediment that's moving there. Whenever you start to look at like riverine inputs or stream inputs, the dynamics become a lot more complicated. Also, there's not always a lot of good measurements to help parameterize the models for those smaller scale riverine inputs. But again, we're really focused on what's going on in the coastal zone here, particularly the near shore and estuarine regions.
Hey, thanks for that. And just to explain the reason why I asked, I'm not an expert. And it seems to me when I look at efforts to model, sediment dynamics, they seem to usually focus on either one or the other, things that are happening in streams or things that are happening in the coastal ocean. And I was just wondering if the difficulty of doing both is the reason why we aren't doing both, or maybe that it just isn't necessary to do that to address the issues that we're generally studying.
Yeah, it's really a matter of the complexity in, the hydrodynamics offshore and compounding that with what's going on in the riverine systems. And it makes it a complicated problem to answer, but there certainly is a lot of research being done on that front, particularly when it comes to extreme events like storms.
Thanks.
All right. Thanks, Davina. Thanks, Mike. And then Stephanie brings up a point sort of just highlighting the use of either structured decision-making or just decision analysis in this work. And I know several groups are going to as well. So that's a really powerful approach. Do you want to offer any thoughts on that, Davina, before we move on?
It's something that is relatively new to me within the past 5 years or so of my research, but I totally agree. It's very effective when you're dealing with a multifaceted problem, particularly for these restoration assessments where you're looking at multiple restoration options and you're trying to align them with what the management objectives are. So I found that it has been effective for, understanding trade-offs and that type of analysis.
Excellent. Thank you very much. All right. And so we're right on time. Our last speaker of the session is going to be Mike Anto.
Thanks for the invitation to participate in the workshop. Today I'm going to talk about how migratory birds connect to landscapes. First, some background information to set the stage. For birds, spring migration is the most energetically stressful period in the annual cycle. Because it is a period with some of the greatest energy demands, yet there are scarcest food resources available. Furthermore, available resources at spring stopover areas drive survival and recruitment rates of populations. So if there are any habitat bottlenecks during the migration path, these can have a large impact on other landscapes due to their connectivity from migratory birds. In fact, a migratory bottleneck was the primary reason for inclusion of the Platte River into the PES program. But notably, the prairie pothole region provides critical refueling habitat for waterfowl, shorebirds, and waterbirds from all of North America's flyways. The prairie pothole region is a globally important wetland resource. It produces over half of North America's ducks and is important for many other water birds and grassland bird species. To kind of demonstrate that importance, on this map down here, the green dots represent hunter-harvested ducks that were banded in the PPR. This region is also critically important for agriculture. Land use changes from ag threaten grassland and wetland ecosystems in this system. Because the PPR produces or provides critical migration and breeding habitat for so many birds, I'm going to focus the rest of my talk on wetland ecosystems of the PPR. The PPR's wetlands have a great deal of variation in size and hydroperiod. The productivity of this system is largely driven by hydrological dynamics. For smaller wetlands, this means short-term ponding dynamics. But for larger wetlands, this occurs over years during wetting and drying periods. Periodic drying of wetlands allows for nutrient recycling and enhances their ability to produce food for birds. Within a watershed, these wetlands have limited connectivity. Groundwater connections are important, but they're slow. Surface connectivity only really occurs when conditions are extremely wet, and this happens through fill and spill dynamics. However, water birds connect these wetlands together because often their daily and seasonal needs are met through using a number of these types of wetlands. Efforts to improve this region for agriculture have resulted in drainage of over half of the wetlands in the PPR. This typically has been focused on smaller and shorter hydroperiod wetlands. However, due to the rolling topography, drainage attempts have resulted in consolidation drainage. Now, this is where smaller wetlands higher in the watershed are drained into larger ones lower in the watershed. This practice effectively increases the contributing area of the terminal basin, making it progressively increase in size until it reaches its spill point, when it generally stabilizes. Now, once a wetland is at its spill point, it tends to shed water into higher order watersheds. This threatens increased connectiveness of the PPR to issues with flooding and Gulf hypoxia. Observed climate change has greatly accelerated this process in drained wetlands as well. Now, these changes have big ecological consequences. Now, first off is the loss of shorter hydroperiod wetlands that are critically important for birds in this region. But secondly, the stabilization of long hydroperiod wetlands leads to ecological regime change in favoring invasive species. Owen already talked about the complexity of the wetland systems here, but considering bird response really ratchets up the complexity. So we generally overcome this complexity by doing large-scale multidisciplinary studies. And we try to account for this complexity, but at least with large scale, we're able to average over the uncontrollable noise in the system. We also lean pretty heavily on remote sensing and spatial modeling technologies for additional control and understanding of mechanisms and drivers. More recently, though, we've been developing tools to use existing field data and spatial data to inform predictive models that can greatly improve our efficiency of field data collection and monitoring. And then in turn, after we collect that data, we can come back and update those models with Bayesian style updating, which generally yields a much better result. The concept of habitat requires a determination of a focal species or a suite of species and an understanding of how that species is associated with environmental characteristics. Now, often we have a focal species or a group that we're interested in, and so we generally flip that notion over, and we use birds as a sampler for understanding habitat features and quality. Now, birds vote with their wings, and so occupancy or numerical response often is a good proxy for habitat condition. We can also assess their body condition or diets and compare diets to foods available in their environment. We have various ways to index their productivity or recruitment as well as survival. Together, these metrics can inform what features comprise habitat and help make inferences to habitat quality and identify stressors that influence populations. However, habitat for a species does not directly equate to ecosystem health unless you are working with a well-selected umbrella species. This may be something we want to discuss further in this workshop, since it's focused on the concept of habitat vulnerability. Now, for addressing information needs along migration and dispersed breeding populations, we frequently use various forms of tracking tags. Technological advances here have improved the quality and frequency of position data, but also the inclusion of accelerometers on these instruments allow for the collection of activity data. This tech allows us to make a number of behavioral influences and is really leveraged well with remote sensing and spatial modeling procedures. Considering the history of land use changes in our region, the Landsat record has been extremely valuable to us. Additionally, it allows us to leverage legacy field data and put it into a spatial context. Now, the recent addition of pre-developed products that we can model within a Google Earth Engine environment has really been a game changer for our workflow. However, I'd say that the biggest challenge we have with using these data is the spatial resolution, and particularly with its ability to detect ponded water in emergent wetlands. Now, we're aware that there are some efforts to develop sub-pixel products from Landsat, and such a product, particularly for surface water extent, would be extremely valuable for our research programs. Now, this region has a pretty significant conservation footprint, and that's largely been motivated and funded by waterfowl. Our research has been focused on helping optimize those existing programs as well as informing broader policy decisions that influence conservation. However, our partners recognize that ducks alone do not bring a large enough constituency for conservation to address the threats in the system. For this reason, we have a large research focus on quantifying and modeling ecosystem services that grassland and wetland ecosystems provide in the region. A better understanding of ecosystem services provided by this region, and particularly those that are provided to areas outside the region, is likely to build a larger constituency for conservation in this important area. I'd like to thank you again for the invitation, and looking forward to the question and answer period.
Thanks very much, Mike. Great presentation. Just lost my chat window. So the one comment I saw was from Stephanie about appreciation for using different approaches, in this case Bayesian approaches, to allow you to actually update the model with new information. Do you want to say a word about that?
Yeah, that that has come along due to advances in modeling tools and techniques, but it really has fit well with a demand that we've been seeing lately, or a challenge we've been seeing, I guess I should rather say, is that it's been difficult for us increasingly difficult to find decent sized pots of money to fund new field research. And so it has really forced us to, we want to be able to do field research that is broad scale and over longer term periods. And it's forced us to be innovative, to be able to be more targeted in our research, to be able to still be broad scale and long term with less money, basically. So, yeah.
It looks like a follow-on from Kelly that if I butcher, Kelly, feel free to ask directly. He was asking, how did you collate those data sets? Were they already compiled for you, or does your team have to do a lot of that compilation?
Good question. And I alluded to this a little bit when I was talking about how Google Earth imagery has really been a game changer for us. The availability of a lot of data sets in that environment and the ability to do modeling in the cloud has really enhanced our speed at being able to handle spatial data sets and building those types of spatial models, especially when we're talking about really large landscapes, because in the past, when we've done this, we would have to download things and then image process them on our own computers and have to build up our own computer infrastructure to do that. And we're experiencing that we can do these things so much quicker in that Google environment.
Excellent. Follow up from Stephanie with regard to the ecosystem services work. Are stakeholders asking for that? Or is that an opportunity or an approach you're looking at to sort of bring more stakeholders and constituents into the discussion?
It's a combination of both. I think the stakeholders are asking, are interested in figuring out things that align with what they're interested in, and ecosystem services modeling is a tool that we can use for that. And so, you know, for a while at our center, we've been developing that tool, and of course we're selling it, you know. And so I think it's kind of a two-way street. You know, there's kind of a feedback there with that.
Okay. And then maybe last question before we get into our 15-minute wrap up. Kelly Maloney also asked, they're modeling freshwater habitats and moving to a 1 meter land use rasters right now. Are you moving in that direction yet?
We have for some things. The challenge with going to 1 meter for us in the past has been a couple of things. Our temporal extent tends to get shortened, and because there isn't a longer record of 1 year or 1 meter data available. And then the other thing is just the processing of it. You know, we really like the Landsat record because it's available. It allows us to utilize and leverage our legacy and historical data that we've collected, as well as watching, you know, land use change transpire, you know, and be able to make better sense of it. And it's easy to work with. I mean, the biggest challenge there is that 30 meter pixel. We really have there's a lot of limitations with it. And, you know, there are some smart people that are trying to crack that nut. And, you know, I think it'd be great if they could sort out a little bit where we could extract a little more information from that, a little bit coarser level of resolution.
Excellent. Thanks, Mike. So what we'd like to do, we've got about 11 minutes left until we hit our break. And I thought the last kind of 15-minute wrap up we had worked really well of just folks jumping in, offering thoughts on either questions for some of the 5 speakers that we had, common thoughts. I guess Tanya had one in there about a common thread seeming to be this management, or maybe it's management and restoration. So I'd love to open it up for discussion from folks. So I see Karen's already got her hand up. Perfect. So go ahead, Karen.
Hi. I guess I'm going to talk first during all the discussions. So I just wanted to comment with the different sort of migratory bird talks. I put it in the chat that it was definitely a cross-cutting theme. That's not what I do, but there's a lot of people here that do that in the integration. And they already sort of, like, all PIs sort of work together ad hocly, but to have some sort of synthesis, I think would be really, I'm speaking for them, would be great probably. Because I can tell you that I know of PIs that are also building decision support tools for the Pacific Flyway and over the next couple of years. So that seems like a really good crosswalk also, and has, you know, the changing habitats under climate change, all of that. Migratory animals, it's so complicated. I feel for you guys. Because you have multiple habitats changing, breeding grounds, nesting grounds, and everywhere in between. So yeah, I really think I'm going to plug that. I think it's really important. It's not something that I do. So.
Thank So yeah. I see Owen and Mike, Anto, you had your cameras on already. Do you want to respond to that? And then someone else, go ahead. I'll let you respond to that, and then we'll see if anyone else wants to comment.
Go ahead, Mike.
Yeah, no, I mean, there's always a need for more coordination. And so I think that's kind of always our challenge when we're working in our own systems and we're kind of, you know, struggling to conquer our own complexities and everything. So, but yeah, I definitely can agree that there is definitely connectivity, and the same species are hitting in some of these areas. You know, the San Francisco Bay is important for a number of species that even come through the Prairie Pothole region in some years. So it's there's definitely a lot of connectivity with migratory bird needs, essentially. So.
Owen, anything you wanted to add on there? And then we'll go to Mike Osland. I think you had your camera on, so maybe that meant you wanted to add, maybe not. But Owen?
I was just thinking about, yeah, the if we focus on the migratory bird sort of story, this definitely translates across at least the continental U.S. and beyond, and groups like the joint ventures and flyways councils and things like that really kind of have to think about these things at the landscape scale, and hopefully we can bring our kind of local expertise to what's the issues in our neck of the woods and what types of interactions between these different change drivers should we really be focused on.
Yeah, great points. And Karen, certainly in Chesapeake, we've got a fairly extensive waterbird effort. I know there's some collaboration with San Francisco Bay, Delaware Bay, a few others, but I certainly couldn't describe how far that goes. So Tanya had her hand up, and I guess Kurt does as well. Are either of them related to the waterbirds, or is it the next topic? Tanya says no, Kurt. So let's go Tanya, since she had her hand up next.
Okay, thanks. So a couple of things that also I saw while you guys were talking. One was obviously the connectivity of the landscapes, which we've been talking about in the previous section. But the idea of water management, like who's the driving force or the kind of the decision maker in terms of water management, is something that we see even within, the Great Lakes, depending on which state you're in, depending on what level of question you're asking. So for example, if I think about tile drains and drainage ditches, which I know extend into the flyway, some of the states have permits before, in theory, these new systems are supposed to be going in, and in other states, they're a completely private entity. And in some ways, even understanding that difference and how it can be related to the connectivity, I think in some ways could help us understand how different parts of the landscape might be restored or recovered. Just because as I work with people in different areas of the country, I learn more bits and pieces about the decision and the local politics and how that ultimately ends up affecting water quantity, quality, and everything. So I'm curious to learn more about that as we move forward.
Absolutely. Great point, Tanya. So Kurt, I think you're next, and then Mike.
I echo the idea of connectivity. You're going to hear me talk about it next in my talk, but in a little different way. So I echo that as a good theme to keep thinking about. But my point was going to be about decision support systems, decision support tools. I also will be talking about that a little bit, but hearing the great presentations so far, I think a theme is how we communicate our science with geospatial data, big landscapes, how we communicate that to the stakeholders, our partners, whomever we're trying to target, and always be cognizant of, do people want what we're producing? Are we pushing the ship? Are we being asked for something specifically? There's lots of discussion we could have about that, but I just offer it now as maybe a placeholder for see if it comes up later.
Yeah, great point, Kurt. Thank you. I know that we struggle with that for sure in Chesapeake. Mike Chakowski.
Yeah, thanks. Those were really engaging talks. I appreciated them a lot. I'm sure I'm not the only one. One thing I didn't hear a lot about is water quality other than salt and sediment. And I apologize if I did hear it and I just didn't register it. But is anyone in any of the who's spoken already aware of any issues that are water quality related that might arise as a consequence of ongoing climate change, surface water quality?
I think, Tanya, your hand is still up, and certainly I'm thinking your presentation had some phosphorus water quality components, yes?
Yes. So, I mean, they're at its simplest, I think even stream temperature and groundwater temperature is likely to be changing as that balance between the two changes, surface water and groundwater, but also as storms move through the landscape more quickly. In terms of nutrients, yes, some of it we see that there's ample evidence that not only is it going to maybe move nutrients that are still up in the uplands of the landscape, but remobilize material. So when we talk about the legacy sources, one of the reasons we're so interested in trying to inventory them is that as stream energy increases, there's an ability to maybe flush things out that have been stored there for quite a while. There's actually a discussion within the MOMI system, at least, that while the stream bank goes in and we know it takes phosphorus with it, in the end, as I was trying to show you, it ends up being a lower particulate and amount of phosphorus moving. And there's a discussion going on as to whether or not sediment that's sitting in the stream network is actually holding phosphorus for us, that would otherwise be moving directly into the lake in a much shorter time period, but that those storms could be moving it. And I can't really speak to the nitrogen enough to tell you, but there's also that caveat in terms of how it's going to be moving groundwater nitrogen and also changing how much denitrification is going on. Did that answer it all?
Yeah, thank you.
When you had your hand up, I wasn't sure if that was a remnant or you wanted to add to Mike's question on water quality.
I could, but I was going to just dump it in the chat if we didn't have time. But we're dealing with those types of issues up here in the prairie pothole region as well, with grassland to cropland conversion happening, wetland drainage, and then as Mike showed, the consolidation drainage is really, once we have those extreme wet events, it's really connecting the landscape and moving those nutrients off of the uplands and into the aquatic systems and down into the Gulf and other places.
And I would add, for us in Chesapeake, there's an awful lot in the way of changing nutrient sediment dynamics, and then in particular how management is on one side of the equation and climate change and land use are on the other. So driving it in different directions, trying to untangle those is a big area of emphasis for us. So, all right, any other hands up, any other questions? Maybe I'll ask one. I've seen an awful lot today about restoration and driving management decisions. I wondered to what extent folks are wrestling with setting conservation directions as well. So we saw a little bit of that maybe with land acquisition for driving marsh migration. I thought I saw more about restoration than I did about driving conservation, and didn't know if anyone wants to sort of say, well, we are using it for more conservation work too.
I can speak to that a little bit in our region. Like I mentioned, there is a pretty good channel of funding to bring into the region that is directed towards enhancing waterfowl habitat. And so that is a lot of the stuff that Owen was talking about really relates to that, and a lot of the research that I'm seeing getting a message of having audio issues.
Yeah, it's just we're hearing it twice. I'm not sure if that's because someone else was unmuted or not, but okay. Thanks, Mike.
Yes, the answer is yes from the prairie pothole region and the mid-continent, and that's something we're trying to sell or trying to feel, even if we're not using the explicit terms ecosystem services, is trying to see how different stakeholders see these conservation issues from the water quality and the habitat side.
Well, I appreciate that, and maybe for time we'll wrap up there. Thank you all. Thank you to all 5 of our speakers. That was another round of great presentations. So we are on break till 4 o'clock. And so the modified challenge I'm going to offer to everybody is to come back at 4 with the same energy we've had so far. I know it's kind of a fire hose of presentations. So we'll talk to everybody at 4. We'll kick off again. And again, thank you all. Great discussion, great content, and talk to you in a few minutes.
If I do a mic check, is anyone listening now?
Still funny.
Bad.
Yeah, Mike. Still getting bad feedback.
Hey, Mike, what I would suggest doing is logging out of Zoom and then back in during the break. That may fix it.
Give that a shot.
Oh, you suddenly sounded better.
Yeah, but it goes back and forth. He sounds great now.
Okay, well, I just cycled which microphone I was using, and
yeah, that sounds great.
It sounds great. You might have fixed it.
Good, thanks.
Okay, I need to stand up. Oh.
Hey everyone, just a 2-minute warning, kind of start wrapping up what you're doing on break, and we'll get started here in about 2 minutes. Okay, so we're getting close. I assume most everyone's starting to check back in here. Just a couple quick notes before we get started. So we've got 6 talks in this last session. And as Ken noted, please do your best, stay engaged. We've had 2 really great sessions. I expect we'll have 1 more, and we'll have a little bit of extra time here at the end to have that discussion over these 6 presentations, and then we'll have a quick wrap and prep for tomorrow. So with that, Breck, I think if you are ready, we can start with Kurt Kowalski's presentation.
Good afternoon, everybody. My name is Kurt Kowalski. I'm a research ecologist at the Great Lakes Science Center based in Ann Arbor, Michigan. So as you may have read in my bio, my research program is focused on wetland and invasive species issues in the Great Lakes Basin. I'm not going to be speaking today for everyone in the basin, all of the issues at the Great Lakes Science Center, but I'm hoping to share some of the work that I do and some of the key concepts that we try to employ both in my research program, but also throughout the Great Lakes Science Center. And what I'm going to be talking about are really issues that are prioritized by the 8 states, 2 provinces, and many tribal and First Nation groups that are in the Great Lakes region. My team and I are lucky enough to work at sites like this wetland system in Braddock Bay in Lake Ontario. It's one of the many freshwater coastal wetlands in the Great Lakes. Other than saltiness, I'd argue that our coastal systems function much like their marine counterparts, both in value and stresses, and really provide that critical interface between the landscape and the lake depths, which, as we know, is very vulnerable to changes associated with climate change. The coastal wetlands occur on over 10,000 miles of coastline that surround the Great Lakes. As comparison, that's a little bit less than the Atlantic Gulf and Pacific coast together. So extensive amount of shoreline that surround these lakes. There is great variability in the lakes themselves in terms of depth and temperature. Colder, deeper Lake Superior to the north. Other lakes like Lake Erie are shallower. Lake Erie has an agricultural watershed for the most part. So there is diversity among the lakes and of the shorelines that surround them. As I think about the main drivers for coastal wetlands and these coastal systems overall, I think about water levels. I have Lake Erie water levels in the upper corner there, upper left. The actual elevations aren't important, but notice the variability through time. There's variability on the short-term scale. We have wind-driven seiches that operate very much like lunar tides on an hourly or a couple-day time frame, but there's seasonal patterns, there's annual patterns, 10-year, 30-year, and beyond patterns. that variability is critical to driving the coastal wetland ecology and many of the processes on the landscape. That variability also, or as a result of that variability, there's this moderate level of disturbance that often occurs. And so as we think about vulnerabilities of this system to climate change, and some of the results that the models are predicting include increased amount and frequency, or increased frequency and magnitude of storms, putting water on the landscape, as well as driving differences in water level fluctuations, greater extremes, more rapid change, those types of things. That can have impacts on the shoreline, thinking about erosion. You see the picture in the middle there, especially for the areas that are not protected by revetment and other hardening of the shoreline. Changing patterns of precipitation in the landscape are anticipated to impact the amount of nutrients that flow into Lake Erie, like you see in the picture on the right, and those nutrients are drivers of the harmful algal blooms that are already a problem in the lakes that impact drinking water for millions of people. We also think about the impacts of and the vulnerabilities to invasive species. So as I told you earlier, I focus on coastal wetlands, but also think about invasive plants, particularly the invasive Phragmites australis in the bottom right-hand corner there. That is already established, but it's anticipated that plants like this will increase their range and maybe change how they're growing and the impact that they're having on the landscape. But common carp, as you see a picture of me there, and other organisms are anticipated to increase their range and change the ecology of the lakes. The priorities, both of my research program, but so much of what goes on in the management and research realm in the Great Lakes is driven by, currently, or since 2010, driven by the Great Lakes Restoration Initiative. And the GLRI, the Restoration Initiative, is guided by action plans. Since 2010, over $300 million of congressional money has been funding this through that it gets distributed by the EPA to federal agencies, states, and other entities who are implementing restoration and management on the landscape. The priorities are articulated within the action plans, and I highlight 2 of the 5 major focus areas: invasive species and habitat and species. Those are the areas that my research program fall under, and also are likely to be impacted greatly by climate change. One of the concepts that we employ at the Great Lakes Science Center and throughout the Great Lakes is this idea of collective impact, an idea originally developed or put out there in 2011 by Kenny and Kramer to attack a social problem. They list out conditions for success. I'm not going to go through those, but the idea of collective impact is that there's close coordination and sharing of information and metrics to improve and create this additive effect of all the actions towards a common objective. Like the image in the bottom right-hand corner, it's not just collaboration, not bumping into one another, but it's this additive effect to maximize the impact towards a problem. One of the ways that we've implemented that is through the USGS Great Lakes Science Center, working with the Great Lakes Commission to stand up a collaborative, the Great Lakes Phragmites Collaborative, that is focused on pulling together and maximizing the impact that all of the people, research, policy management, and so on, are having on this invasive Phragmites australis. Notice the web page in the middle there, web link there. I encourage you to go check that out. But the resources you see there are not the collaborative. The collaborative are the people and organizations that are working together towards this common idea of limiting the impact of Phragmites on the landscape. And Phragmites is a big deal in the Great Lakes Basin, but it's really a nationwide problem, and many people are thinking about it and working on it. One of the priorities identified by the Great Lakes Phragmites Collaborative was to identify best management practices for this species. So USGS worked with the University of Georgia, Great Lakes Commission, and others to stand up the Phragmites Adaptive Management Framework, which is using this idea of adaptive management in order to reduce the uncertainty around which management practices are the best for this plant given certain landscape conditions. You see the website there down on the bottom. You get more details on the program. I encourage you to go take a look. This might be a model for other areas to consider for this species in other locations, or other species, or potentially other applications. Another priority that the Phragmites Collaborative has identified is for more tools in the toolbox. So I and many partners have been working on developing new control strategies that could be of interest to this group and for other parts of the nation. Our first effort is focused on using the microbiome, or the relationships between the microbiome, bacteria, fungi, and invasive plants, and targeting that relationship as a potential form of control. We took this idea of collective impact and stood up the Phragmites Symbiosis Collaborative, lots of different partners to coordinate the science effort towards evaluating microbes as a potential control mechanism for invasive plants. The other main research theme is focused on developing genetic biocontrollers, species-specific controls to minimize the impact that Phragmites and other invasive plants are having on the landscape. This fits in very closely with the existing USGS synthetic biology community of practice. It's an open group for people to be part of. It has been very beneficial to be able to expand my research on this plant and our approaches with gene silencing or RNA interference, but comparing those and talking about those efforts in comparison to some of the other efforts that are going on within USGS. Now we'll round things out here by talking about coastal wetlands more, my other main research theme. One of the main strategies that we've been working on is focused on the connectivity of these coastal wetlands. Through time, most of the coastal wetlands have been either degraded, destroyed, or isolated from the lakes, and thus that moderate level of disturbance that I talked about with fluctuating water levels. There are these earthen berms, so as a restoration strategy, there's been several examples of reconnecting the dike wetland back to the parent water body to allow the exchange of nutrients, to allow the movement of fish and reestablishment of water level patterns that drive a more diverse biological community. And this has been implemented throughout the Great Lakes Basin, lots of examples among all the different lakes with great success. Restoration assessment. This is a geospatial analysis that we've done that has developed, that has produced several different assessments of what areas in the coastal zone are most restorable back to coastal wetland. We have worked with the web informatics team and other USGS offices to develop a series of mappers, online mappers, a nice geo-narrative. You see the website in the middle there with lots more information. This is another model to help with decision-making and planning for coastal managers as they think about the impacts of climate change and have to make decisions in this very dynamic system. I don't have a slide about needs, but I will offer that continued development of data as well as these information tools that help communicate our science to managers are two areas that I think we can continue to work on within the Great Lakes Basin. Thanks.
All right, excellent. Thanks, Kurt. So I noted that Kurt put a couple of links into the chat. I don't see any specific questions at the moment, so I will let folks think about that. Actually, here's one from Mike. So Kurt, if you're seeing the chat, for wetland connectivity work, what kinds of ecosystems, land uses are typically on other sides of the dikes?
Yeah, thanks, Mike. So historically, the wetlands extended, gradient up the landscape and would move up and down the landscape, much like you described. And now, well, through time, drainage, farming, tiling, hardening of the shoreline has really brought that backside and hardened the upslope side of these dike wetlands. So generally behind the dike, so you have open lake, then you would have a dike wetland. Behind that, oftentimes farmland is what it would be. It may still be low elevation, a lot of tiling and pumping that goes on to farm those former wetlands. So they're super nutrient rich, very productive farmlands, but maybe at an elevation that our model helped identify as restorable back to coastal wetland. But generally farm, but there is in the urban areas or in developed areas, pavement now and people living there, that kind of thing.
All right, great. Thanks, Kurt. And I know Tanya just shared another link in there as well. Okay, so let's, since we do have 6 presentations, let's keep moving. So Breck, if you don't mind, let's bring up Kelly's presentation and we'll move on to that.
Hi, everybody. I'm Kelly. Hi, everybody. I'm Kelly Maloney. I'm a research ecologist at the Eastern Ecological Science Center at Leetown office in Kearneysville, West Virginia. I'm involved with the USGS Chesapeake Bay Watershed PES project. Today, I'm going to talk about our projects related to assessing stream habitat and biological condition for non-tidal streams in the Chesapeake Bay watershed. For those who are not familiar with the Chesapeake Bay watershed, it resides in the northeast part of the United States. It drains 6 states, or portions of 6 states, including New York, Pennsylvania, West Virginia, Maryland, Delaware, and Virginia. It drains 64,000 square miles, has about 11,684 miles of shoreline in the estuary, 150 major rivers and streams, and home to over 18 million people. The landscape context of my presentation and the research I'm going to present is all streams and rivers in the Chesapeake Bay watershed, all non-tidal ones. And we're going to take a multidisciplinary, multivariate approach looking at physical, chemical, hydrological, and biological endpoints. I'm a biologist. I focus more on the biology, but a lot of my collaborators in USGS are handling the other endpoints. What are threats and vulnerabilities to habitat from climate change? The figure on the right here is projected 2090 median increases in temperature from the CMIP5 scenarios, downscaled by Lauren Hay and Greg McCabe, USGS. And this is temperature change. And the dark brown is 5.6 to 5.7 degrees centigrade projected increase in temperature. In the Chesapeake Bay, this area where you see this brown is home to a lot of cold and cool water systems. So the first thing we're going to see is potential changes in temperature and stream temperatures. But also in this area, we have projected increases in both frequency and intensity of rainstorm events. So we're also going to see hydraulic altered flows. So altered flows and temperature are going to alter the habitat and then result in altered biological communities. What are the resource and habitat management challenges identified by stakeholders? The Chesapeake Bay program is our major stakeholder, driving a lot of our research that we link our research to their needs. This is a pretty large program consisting of multiple levels and elements like the Chesapeake Executive Council, Principal Staff Committee, Management Board, Advisory Committees, Communication Work Groups, Scientific Technical Assessment and Reporting Groups. But where the science really happens is over here, where the goal implementation teams. This is where the science and the management meets most often. It happens in other areas, but this is where the stakeholders, the local stakeholders, the regional, state biologists talk with the researchers and hammer out the needs and how the science can manage and meet those needs. There's 6 goal implementation teams, and in each of those, there's 3 or 4 action teams or working groups. I can't go through all of them. I would spend a whole day on them. But 2 of the ones that are directly related to the research I'm going to talk about today is the Fish Habitat Action Team, which is within the Sustainable Fisheries GIT. And their outcome is to continually improve effectiveness of fish habitat conservation and restoration efforts, not only in the non-tidal portion, but also in the estuary. So they're really concerned with assessing, restoring, and protecting fish habitat. The second work group is a stream health work group. And this is under the Habitat GIT. And they have an outcome to continually improve stream health and function throughout the watershed, improve health and function at 10% of stream miles above a 2008 baseline for the watershed. So how do we ensure our work is addressing these challenges? Well, not only researchers within the USGS Chesapeake Bay program, also the science team leads are embedded on the working groups. We're directly involved. We attend all their calls to know what needs are coming and even provide science to help identify potential needs. A few examples of these: the Fish Habitat Action Team needed an assessment of fish habitat for the watershed. This was identified in 2017-18 time period. And we assembled a team of USGS scientists from multiple mission areas, as well as multiple science centers, to put together an assessment and meet that need. And we recently published a paper in Ecological Indicators. A second example, the Stream Health Work Group had a need to establish a baseline estimate of stream conditions. They had numerous observed data, but with hundreds of thousands of streams in the watershed, there's a lot of areas that were missing data. So we partnered with the Interstate Commission of Potomac River Basin to predict those unsurveyed locations to try to fill in that baseline estimate. And a final example, the Stream Health Workgroup had a need to better understand what factors lead to functional uplift or degradation. And a few of my collaborators from the USGS are working with the Stream Health Workgroup to identify the key stressors with literature review. For all these projects, we are constantly presenting updates, getting feedback to make sure what the science we're doing is tied directly to the science needs and optimizes the utility to those managers. What tools and approaches are we using? Again, it's a multivariate, multidisciplinary approach. So we have lots of endpoints: biological, water quality, nutrients, ecological flows, temperature, hydrogeomorphology, to name 5 of them. We're trying to look at the entire aquatic ecosystem to not only provide information on altered biological state, but also potential mechanisms within the stream of why that biological system has changed. Although it's highly diverse, we all use basically a similar technique. We collate large data sets. We collate observed data from a lot of the stakeholders themselves. And that gets buy-in from them again. We're using their data to put in a regional context. And we can actually put their results, what they're finding, into a much larger regional context, and they get excited about that. We're also using landscape predictors, urban land cover. We're assembling a large data set on that, something like urban land cover, agricultural land cover, and natural variables like elevation, soil structures, to name a few. All the endpoints are then building models for prediction to try to predict, just like a general additive model or a random forest model, to try to figure out if we can identify key drivers and relationships between the endpoints. But also these predictive models can then be used to extrapolate and predict outside the observed data. We are also doing status and trends on data sets that are observed that have long-term, and these we can look at maybe potential changes over time. All of us are using NHD framework as a base layer, either version 2.1 or the high res, and we all have an interest in incorporating climate and land use change scenarios. As an example, in 2020, here's another multiple mission area science center and stakeholder project where we use Lauren Hay and Greg McCabe's downscaled CMIP5 climate change projections and Terry Sol's group's AROS land cover projections to predict out what stream conditions based on benthic macroinvertebrates would be in 2090. And this is important for something like the Stream Health Workgroup, where they have an objective or an outcome of improving 10% of stream miles by, say, 2030. Well, if you preserve and improve 10%, if climate change and land use change is going to further degrade another 10%, well, maybe you need 20%. And they're really interested in this. And we presented this results to other working groups like the Climate Resiliency Workgroup and the Chesapeake program. How are managers using the information in decision making? The USGS science is identifying key stressors of ecological alteration. This helps managers pinpoint, the most important ones to change, or if it's multiple stressors. Predictive modeling reveals large-scale patterns, potential conservation and restoration locations, and locations sensitive to future changes. Again, I mentioned there's hundreds of thousands of streams. It's virtually impossible with limited resources the managers have to go out and sample all of them. So our models are going to hopefully help them prioritize areas. We often caveat this, though, and make sure they're aware these are model results. They need to follow up with site visits and surveys. And the status and trends analysis highlight areas improving or degrading. And the improving could be a result of best management practices. They're very interested in that. They're spending lots of money in Chesapeake Bay, and they want to see ecological lift. Very hard to prove, but with these long-term data sets that they're collecting, we can kind of get an estimate of regional scale approaches. And then also degrading, most likely from land use changes. What have we learned that might be useful and transferable items to other large landscapes? Well, again, a large multivariate, multi-scale approach. A lot of researchers were using and leveraging the expertise of geomorphologists, hydrologists, water quality experts, biologists, bring them all together, and it's really improving our approach and actually our message to our stakeholders. The research is actively involved in the GITS. I cover this a lot, but constantly working with them, talking with them, getting to know their needs and what we're capable of has really pushed the envelope forward and really helped us, help them meet their needs again. And then data collation and modeling lessons learned. We collated over 30,000 fish data points. The ICPRB had 30,000 macroinvertebrate points alone. Similar efforts on the other endpoints. Multiple agencies, multiple data collection methods, and we had to learn how to connect them all. And we're doing a lot of modeling as well, so a lot of modeling expertise. What are tools, approaches, or applications everybody else is using that might be applicable in the Chesapeake Bay. I think that's probably the major outcome or task of this workshop. So I'm excited to see and hear what people are doing. But two things that I could think of is potential other land use and climate futures people are using. Can we improve upon what we're using right now? And then other methods that have been successfully used to engage stakeholders. What are your techniques above and beyond what I presented that we might be able to apply in our system? Thank you.
Okay. So thanks, Kelly. I was just kind of working my way through the chat here. So Tanya made a note about incorporation of small streams, and I know we do a lot of that in our watershed work in the Great Lakes. Nick makes a really interesting point about the different landscape areas and kind of what structure that USGS is working in. I'm going to hold that for a minute because I think that's part of a larger conversation. So I think then, I don't know that I see any other specific questions to your presentation. I don't know, Tanya, was there anything you wanted to expand on related to the small stream concept? I'll call you out quickly.
Just the idea of looking at the effects, the fact that the land use forecast may cause one change and the climatic projection may be causing a different change, and seeing it at those small basins is kind of key, because by the time you get it up to the larger ones, it's hard to know what's doing what. So that's really appreciated.
Great, thanks, Tanya. Yeah, and on this idea of kind of the, maybe the governance or the structure that we work in, I think there are differences, and I think let's bring that up again during our wrap up here at the end, because I do think there's maybe something that we can, some string we can pull on there a little bit on that piece of the conversation. So with that, I don't want to get us behind. Let's go on to Stephanie's presentation, Breck, and we'll go from there.
Good afternoon. My name is Stephanie Remignac, and I'm a research ecologist based in South Florida. My research program in the Everglades wetland is focused on helping my federal and state agency partners to get the science they need to inform restoration decision-making and conservation planning. I'm going to go out of order a little bit on these slides, just to tell you first about the restoration initiatives that are underway. Everglades restoration involves implementing many tens of restoration projects, and it's going to take decades to complete. As you can see, there's a pretty hefty price tag for it too. If you've worked in the Everglades before, I'm sure you've seen this graphic before or some version of it. And I'll just show you what it means here. So on the left, you can see the green showing the former extent of the Greater Everglades in the 1800s, before people started developing it. So that's when water was flowing nicely south. In the middle, we have the situation that we're in today, with a much more restricted flow of water after people started draining the wetland, essentially creating canals and levees so that they could use the land for agricultural development, residential development. And then on the right, you see what we're aiming for with restoration, which is to get more water flowing south again. In the last couple of years, the biggest threats that we've been talking about in the Everglades are those of sea level rise at the coast and also of urban expansion. And a couple of years ago, my research team worked on a project and found that by 2070, we're projected to lose up to 47% of our coastal uplands. And as these homes become flooded at the coast and insurance costs for these homes keeps going up, and 1,000 people a day are moving to Florida, urban projections are showing people moving inland into the central Everglades, which is the heart of the Florida Wildlife Corridor. I run a group known as GEM, Joint Ecosystem Modeling. We provide decision support tools for conservation and restoration planning. And we do this through developing predictive ecological models and data visualization and decision support tools broadly. We're a group of ecologists, hydrologists, computer programmers, and others that work to meet the needs of those making decisions in the Everglades. Some of our partners' logos are shown here, and these partners sometimes provide staff time to help develop the tools, sometimes they provide funding, or they do both. And so our primary focus is on decision-making for the restoration of Florida's Everglades. And so everything we develop, whether it's desktop tools or web-based applications, it's all what our partners have asked for. And we tailor these tools to the decisions that they're trying to make. This is the current core GEM team. There are many others who've played roles over the years, but this is the group that's been around for a while now and has worked on what I'm presenting to you today. One of the things that we developed now a decade ago, but it laid the foundation for collaboration with our partners, it was the development of data standards. We spent 2 years working with our agency partners to develop metadata conventions, and we did this for NetCDF files, so that we could get to both orthogonal and unstructured grid metadata standards. And this really allows us to collaborate, to share data, and the result of that was allowing us to use a common set of decision support and visualization tools. And these standards are so useful that people outside the Everglades have adopted them. And in fact, just in the last week, I've received emails from other parts of Florida and even from California with people wanting to make use of these standards. It really is the foundation for being able to work together effectively. Another one of the tools that I'll talk about are these predictive ecological models that we have developed over time. And they're for a suite of species and habitats that our partners are concerned about in Everglades restoration. And so they might be endangered species like the Cape Sable seaside sparrow, or iconic species like alligators and wading birds that people come to the Everglades to see. So when restoration planning teams are trying to narrow in on the set of projects that they're considering implementing, we take simulations of what those projected hydrologies might look like, and we run those through this suite of ecological models so that the planning teams can see which of their proposed sets of projects are most likely to give them the desired outcomes that they're looking for, particularly for the most vulnerable parts of the landscape. The final tool that I'll focus on today is one of our newer projects, which is the Everglades vulnerability analysis. This project is led by Laura DiCunto in my lab. Laura can't be here this week, but hopefully can talk with you about this at some point in the future. AVA is a modeling framework that lets us get to a vulnerability surface for the Everglades. We start with inputs, which are the drivers for the ecological conditions in the Everglades, so things like water depth and salinity, and landscape features like distance to coastline. We have ecological model outputs in the form of vegetation responses, species responses. So here in this first version of AVA, we have alligators and wading birds. And we also look at peat soil outcomes. And the distance between an ideal future condition and the model outputs gives us our measure of vulnerability. Our approach is transferable to any geography, and so it can be used by anyone here on this meeting this week. We use Bayesian belief networks to integrate different types of data. You can use expert opinion if you don't have data, long-term monitoring data, which we've used, experimental data, and it can be updated as new data come available. Another benefit of our approach is that we provide the uncertainty associated with model outputs, which is something that we don't see often, but it can really help a decision maker in rounding out the picture, particularly as it influences their risk tolerance is different for every decision maker, and so this can be really helpful. In terms of the last piece, what's missing, what don't we have in the Everglades? A supermodel is one of those things. Louisiana does this well. They have their integrated compartment model, which really takes all of the relevant pieces together into this supermodel. And that would be great to have in the Everglades. And the other thing I'll mention is lack of model documentation. So I will make a plea for open source and well-documented models so that we can collaborate more effectively and really build off of each other's work. That's it. Hopefully we have some time for discussion. Thank you.
All right, great. Thanks, Stephanie. So I see a few of the chats here. A lot of positive reaction to the data standards. That's a new one to me. That's something we've struggled with in the Great Lakes. So I'm curious to hear more about that, I think, over the next couple days. So Kelly made a note about Chesapeake Bay developing data visualization tools. What is EVA built on? So any response to that?
Yeah, it was built in R, which I noted in the chat. But I'll just comment on what you said about the data standards, just to make a note that in the presentation, I mentioned this like kind of collaboration among agencies, and that was huge. But it even facilitated collaboration within an office. And so if you think about, we all come from different backgrounds and different, grad schools and use different, we don't do all the same work. We don't collect data in the same way. We don't do things in the same way. And so, people who were sitting in offices next door to each other couldn't even share data effectively within the USGS or within the National Park Service or within Fish and Wildlife Service. And so it really just opened so many doors within an agency and among them as well.
Great. So I might ask a follow-up as I don't see any other hands. So it sounds like you kind of have your team that data sharing definitely supported. Did you have any issues with maybe other entities who maybe were not as willing to share their data and being part of that process?
Yeah, so we don't, yes, but for different reasons. So we're not asking, in this case that I'm specifically talking about, like the decision support tools and visualization platforms that we developed, we weren't asking anyone to give us their data. We were giving away, essentially we were aiming for transparency, which is a politically dangerous thing, but that's what we were aiming for. And so could we get a kind of a standard platform that everyone who was playing in the Everglades could use that platform and pull in their data? So they had to, voluntarily or willingly convert their data into these formats. If they didn't do it, then no one saw, it was more limited whether people saw what they brought to the table. So they had motivation to do it. We weren't asking them for their data. And so, maybe that in that sense, if we had asked them for their data, which we have on other occasions when we're building models, asking people to share data can be very difficult and torturous for both parties. So there are challenges there. But for these particular examples that I was giving, we weren't asking for the data. We were just trying to provide transparency in decision making, which I can tell you another long story about at some point about how that has created a lot of chaos in the Everglades in a different project. But I think all for the best in the end, because we're objective scientists as the USGS, right? We're just getting the information out there.
Perfect. Okay, so let's move on. Let's go ahead and bring up Dave's presentation. We got 3 more to go, and then we'll have a wrap-up discussion.
Hi, this is Dave Bo. Hi, this is Dave Beauchamp with the Western Fisheries Research Center in Seattle. I'm going to talk about the climate challenges and vulnerabilities in the Puget Sound region using the perspective of resident and anadromous salmonids and their food webs. The reason for this is that salmonids connect all these habitats together, and in this region, we have the Puget Sound region is bounded by the Olympic Mountains and Cascade Mountains, with the freshwater areas transcending through snow, mixed snow and rain, and then rain precipitation zones. through both streams, rivers, lakes, and reservoirs, then transitioning into estuarine delta and nearshore marine habitats before ultimately moving into the pelagic portion of the marine zone. With warming thermal patterns and shifting snowmelt patterns, we're concerned about altering the thermal suitability of habitats for salmonids, as well as fragmenting connectivity to critical habitats among the different life stages that are dependent on these habitats there. In addition, sea level rise can have impacts on the estuarine delta and shoreline habitats particularly, and these are exacerbated by constraints from natural landform and land development in these regions here, as well as altered flow and sediment dynamics. Note that we have a high urbanized area in that Seattle-Tacoma zone, which bounds the eastern side of much of the Puget Sound habitat there. So some of the challenges in trying to manage ecological flows and thermal regimes across these conflicting demands for hydropower, flood control, potable water, and managing for in-stream flow requirements of various salmonids and other species comes into play the need for salmon and steelhead really requiring a diversity of high quality habitats in both these freshwater and marine areas, and those habitats need to be connected in timely fashion in order to satisfy the life cycle so they can complete it successfully. In addition, shifting distributions due to climate change and invasions can create these hybrid food webs where the overlap of predators, prey, competitors, and even pathogens can change even within the existing community, but also when you have invaders added to it. This can change the strength of interactions that regulate populations in quite unique ways. And then we're also concerned about thermal breakouts of both latent pathogens and those that invade due to various pathways cued by climate. So some of the useful tools and approaches that we tend to use are bioenergetics models. These can mechanistically link the individual behavior and physiology of fish to the environmental and ecological conditions that they encounter. And a good example of this is just simply looking at bioenergetics of growth potential for, in this case, a Chinook salmon as they respond to different temperatures and food supplies. And what you can see is that the temperature of optimal growth declines to cooler temperatures as food supply declines, and also that the thermal tolerance of maintaining positive growth also shifts to cooler temperatures as food supply or quality of the food declines. So these are important elements that we can then extend to multiple species to see how thermal responses then overlay with the environmental conditions to influence overlap of species and thus their interactions. And so examples of this could be thermal stratification in lakes or reservoirs where they can vertically segregate or concentrate predators, prey, and competitors. An analogous system can happen in rivers and estuaries, but typically on a more lateral or longitudinal dimension there. So we can evaluate factors that limit production in terms of growth and survival of target species or communities, and do this in such that we're quantifying, say, predation mortality, or the carrying capacity of a system given the existing community, or look at the feasibility of introducing species on top of that existing community. Or this could be translated into if an invasive species comes in, how is that going to have an effect on the existing food web in terms of competition or predation, and the vulnerability of that invader to actually sustain itself given those conditions. So we can assess the vulnerability of species to climate change using these techniques and just flip that question around to also look at the risk of invasions and use this information to evaluate the scope for functional restoration of habitats as well. So thermal structure can influence a lot of the trophic interactions. And here's an example of native salmonids and their thermal responses to temperature, as well as a native predator, pike minnow, which has a bit warmer thermal response, and then an invasive warm water predator, smallmouth bass. If we extend this then to water conditions, when we have thermal stratification in a lake or reservoir, the salmonids are going to have to shift depths in response to maintaining reasonable temperature control when they have that ability to. But that has trade-offs also in terms of the prey that they can access, as well as their interactions with other species. And in this example here, in cooler temperatures in the past, northern pike minnow were segregated during the summer months by staying in the warmest water available. But as warming has increased the temperatures above the thermocline, it drives the pike minnow down into the same zone as salmonids, and so they're interacting throughout the year. Also, hypoxic zones could form in more eutrophic systems that can then pinch fish between temperatures that are stressful and then hypoxia there. So clearly some physical features of the habitat affect the bioenergetic responses, and so we can expand our toolkit by starting to link some of these things together. For instance, using hydrodynamic models, these models can explicitly link to biological processes by, first of all, predicting thermal structure and flow regimes, say above and below dams under different climate scenarios or water operations scenarios as well. The thermal structure and dynamics influence biological rates and the behavior and interactions of fish, and thus we get an insight into how the food web can respond. So if we link these hydrodynamic and bioenergetics models explicitly, we can mechanistically examine implications of various climate and operational scenarios in terms of influencing distribution, growth, or survival, and interactions of various species. We can predict the spatial temporal dynamics and growth potential for target species or their interacting species as well. And this can help us identify opportunities or constraints that could be relevant for water operations or species recovery measures. Fish passage systems for both juvenile and adult fish at dams would really help evaluate feasibility of salmon and steelhead gaining access to more habitat and potential thermal refugia. So this is another tool that can integrate into this type of a toolkit. And then really importantly, I think the telemetry-based mark recapture approaches using, say, acoustic or pit tags can be very helpful in terms of estimating and measuring distribution, movement, and duration of fish within different habitats, estimate the associated stage-specific survival within and among habitats, and then that allows us to link bioenergetic consequences of habitat use and evaluate trade-offs of, say, different life history strategies. And these can all inform life cycle models and then allow us to include climate scenarios or restoration strategies. Here's just an example of linking some hydrodynamic and sediment dynamic models with bioenergetics in an estuary. This is the Nisqually estuary, where this heat map can show how growth potential changes from baseline conditions during current periods to different sea level scenarios, moderate or high, going into the future. Also, an increase in air temperature up to 7 degrees in May. And then also whether or not sediment enhancement might be needed to help keep pace with the mobilization of sediments as sea level rise encroaches, and then a combination of both sediment and air temperatures there. This was a collaboration between our colleagues at the Western Ecological Research Center, Oregon Co-op Fish and Wildlife Research Unit. Melanie Davis is now the assistant leader there. She was the lead author on that project. And then also Nisqually Tribe and U.S. Fish and Wildlife Service. And I'll just conclude while you look at this summary slide. Thank you.
All right, excellent. Thanks, Dave. So I don't see anything in the chat at the moment. Oh, here's one from Judy. So if you see that, do you also look at residence times and food sources, food webs, and how they vary across space?
Yes, and that becomes important, especially in these estuarine habitats where fish could be undergoing a critical period that may only last days or it could span weeks. And so it's pretty important to try and nail that down in terms of specific habitat associations and the consequences of growth potential and their interactions with other species there. That is an area where trying to meld these mark recapture models with the cheaper pit tag and the pit tag arrays is really coming to the fore. And in fact, there's a interest coast-wide along the Pacific coast, including the Canadians, to try and integrate that type of an approach into these sorts of examinations.
Great, thanks, Dave. And I'll just make a comment as well regarding Great Lakes. A lot of things you mentioned, focusing on the bioenergetics, things like that is a pretty common theme here in the Great Lakes as well. A lot of the folks in Kurt Center, Great Lakes Science Center, that are looking at native species, prey fish, that's a big focus of their work. So just wanted to point that out, even though no one from that group is on here today.
Yes, there's a rich history from the Great Lakes region that was sort of the beginning of the bioenergetic approaches. Still a lot of legs to that.
Great. Okay, so let's keep moving. Next presentation is from Karen. So Brett, go ahead and load that up and we'll move on.
Hello, my name is Karen Thorne, and I'm a research ecologist at the Western Ecological Research Center, located in Davis, California. Today, I'm going to talk about understanding tidal wetland processes in the response to climate change to inform decision-making in the San Francisco Bay Delta. The San Francisco Bay Delta is made up of two large regions. The orange circle is the inland delta, which Judy Drexler spoke about earlier. And then the blue circle is the larger San Francisco Bay itself, and I'll be speaking about that today. The San Francisco Bay is influenced by ocean tides through the Golden Gate and also the Sacramento and San Joaquin rivers that receive fresh water from the Sierra Nevadas. The San Francisco Bay is a complicated landscape with lots of challenges as people and wildlife and habitats closely coexist. Non-climate stressors and impacts to the San Francisco Bay include land conversion of wetlands to agriculture and developed, with over 80% of the wetlands lost. There's over 9 million people that live here, and there's continued population growth. Invasive species, both terrestrial and aquatic, and water quality concerns related to water diversion and prolonged drought conditions. Climate change impacts to the San Francisco estuary will include sea level rise, saltwater intrusion, increased flooding, more frequent extreme conditions, so both storms, which can be greater precipitation from atmospheric rivers and other extreme events, persistent drought, terrestrial and marine heat waves, and changes in freshwater availability from lower precipitation, smaller snowpack. I came up with a list of what I consider key management questions pertaining to wetlands, wetland restoration, and climate change. They fall into two general bins of existing wetlands and then restoration projects. Mostly they center around how vulnerable are tidal wetlands to sea rise, what kind of sediment is needed for accretion, and how to best protect these in light of future sea level rise and climate change. Restoration is, do wetland restorations have accretion rates that can outpace sea level rise? Is there enough sediment? How do we even restore in light of climate change? And can we use wetland restoration to meet greenhouse gas reduction goals in California? All of these management questions are cross-cutting. This is just an example of the very large variety and complicated landscape of San Francisco Bay, both federal, state, and local agencies and NGOs. There's large-scale wetland restoration ongoing throughout San Francisco Bay. Most wetlands were lost due to diking for agriculture and salt ponds. It's the largest wetland restoration effort on the West Coast, with over 65,000 acres as a goal. $300 million at least. It will probably end up costing much more than that. But the goal was to increase habitat for protected species, flood protection for low-lying areas, and more public access. South San Francisco Bay restoration plans predominantly include diked salt ponds. There's over 40,000 acres here that are adjacent to densely urban areas. There's a lot of uncertainty around the sediment availability for these wetland restoration projects, and honestly, there's very little climate change planning that's being incorporated. In northern San Francisco Bay, there's restoration plans again. These different greens illustrate if they are ongoing projects, been completed, and who owns them. Again, they're dikes, salt ponds, and agriculture. Many of these lands are subsided, and there's very little climate change planning being incorporated. The first study I want to talk about is a study that is cross-discipline. I'm working with Jesse Lacey at the USGS, and we're looking at sediment deposition patterns in a bay-exposed marsh in South San Francisco. The motivation is that the import of sediment from adjacent water allow marshes and other shallow water habitats to maintain elevations as sea level rise. However, there is much uncertainty on how and when sediment is delivered to nearshore habitats and what those drivers may be. Here is a video of what that site looks like. This is South San Francisco Bay where our tides are higher, but you can see there's sort of a scarped edge there from wind and wave erosion, and that there's actually missing vegetation because of that intense flooding that occurs. This interdisciplinary work includes measurements of marsh deposition across the surface and nearshore and on-marsh platform measurements of sediment transport processes. The second type of study is modeling to inform wetland vulnerability with sea level rise. So the management question is, how vulnerable are habitats to sea level rise? The motivation is wetlands provide habitat for many listed species here in California and other ecosystem services. So when we model habitat projections under sea level rise scenarios, people can use that to understand when are habitats vulnerable, what kind of habitats may we expect in the future under sea level rise without any intervention. And this can be translated to protected species. This work has been done across the West Coast. We also produce maps to inform decision making. We've also done the work in Florida in mangrove and marsh systems, so that it is transferable to other regions. This is Bing Darling National Wildlife Refuge. We've also now developed a 2D modeling approach so we can look at restorations more clearly. This is a restoration in San Francisco Bay where we modeled how it will change with sea level rise over the coming decades. We've delivered results in a variety of ways, both USGS open file reports, manuscripts, and we have built an online story map to deliver some of the work for San Francisco Bay. Next, I'm going to talk about studies where we are modeling to inform restoration planning, considering sea level rise. The management question is how much fill is required to ensure marsh development with sea level rise. Most of these areas are much lower in elevation or subsided, so there's a lot of uncertainty about how much a restoration should be raised so it actually can develop marsh vegetation. We did multiple scenarios that included suspended sediment concentrations, sea level rise, and different fill scenarios. So how high do they need to bring that restoration elevation up so that it does have the opportunity to actually become vegetated in light of sea level rise? Next, I'd like to talk about a restoration that we're monitoring. Dutch Slough restoration was breached to tides in 2021. It's in the Delta. It's managed by the Department of Water Resource. It took decades to plan, but its overall goal was to increase habitat, public access, and be used as a living laboratory to understand how greenhouse gas emissions could be offset with wetland restoration. We're measuring wetland elevation change, water quality, greenhouse gas emissions, both CO2 and methane, using chambers, and soil carbon. I wanted to take a moment to acknowledge the wide variety of projects that are ongoing by the USGS in the San Francisco Bay Estuary, looking at both migratory species and different listed or trust species and their habitat and food requirements. There is a need to further understand how that habitat change will impact these species and is an important management concern. One of our questions asked to us was what could be transferred to other PESs? And the three general themes that I came up with was the sea level rise wetland modeling that we are doing, and the delivery approach is easily transferable to other areas. Studies to reduce uncertainty about marsh accretion and sediment availability for building wetland elevations and restorations. And then also evaluating restoration of wetlands for carbon sequestration potential to offset greenhouse gas emissions. A couple of the needs that I came up with while building my talk is that we really need more case studies on climate change adaptation strategies. What can managers be doing to mitigate for current and future sea level rise impacts? And how do we address changes in storm frequency, intensity, and also drought? What is the restoration potential? How much sediment do we need to meet the restoration goals of the management community? And any links to things people are managing for. And in my estuary, it's predominantly terrestrial wildlife and listed fish.
Okay, great job, Karen. So I'm checking the chat. I note that Nick made a comment about linkages, especially related to vulnerability analysis and the ability for a lot of potentially transferable information and approaches. And I know you kind of covered that there at the end. And while I'm waiting to see if anybody else chimes in, I'd also make a comment that this has been a pretty common discussion in the Great Lakes over the last several months. Your note about climate adaptation, and then I'll also note, and Owen, you may comment on this. I know the Midwest Cask is very focused on climate adaptation in their latest round of proposal requests. So I think that's something that we may want to consider relating vulnerability and then also that adaptation piece when we think about moving forward. Mm-hmm. I don't know, Owen, anything you wanted to tie in from the cask perspective? I know I don't know, you haven't been in there that long yet, but I know that's a pretty big topic for you guys right now.
Oops. It is, yes. Yeah, and I think that'll be a theme as the research priorities and the RFPs kind of come rolling out for this year. And I think really embracing that co-production model, it was something that drew me towards the casks. And again, kind of hopefully showing up in some of our research as we work more closely with managers at the on the ground.
Great, thanks, Owen. And then, so yeah, Karen, I didn't want to cut you off, but any comments on that vulnerability piece and or the transferability of information and approaches?
Yeah, I think in our case here that people have a pretty good sense that, sea level rise is a threat, and there's kind of not and looking for nature-based solutions is what they call it. And so, because we have such an urban developed landscape, like innovation is going to be really important. And so, what are our normal approaches and what are things we haven't thought of yet? And besides building seawalls. And there's, in our case here in California, there's lots of motivation to also do that now before we start seeing loss like other parts of the country are. So.
Great, thank you. Okay, I think we're ready for our last talk of the day. So Brett, go ahead and roll up Sasha's presentation, and then we'll do a wrap up here at the end.
Well, thank you so much for letting me join you all during this workshop. I'm really excited to be here and to both share with you things that we're doing at the Southwest Biological Science Center and to learn about other great science that's happening in our agency. This is really a second talk linked with a talk John Bradford gave earlier today, where he focused on a lot of the threats in the desert Southwest and work that we're doing to try to understand what these threats like climate change mean for our resource manager partners. This talk is going to be a little more optimistic and is going to focus on solutions. It's this same team of scientists, myself, John Bradford, Mike Dunaway, and Seth Munson at the Southwest Biological Science Center, who are working together to try to address some of these big challenges for our Western ecosystems and to think about creative solutions that we can provide to partners to try to combat the changes that we're seeing across these vast landscapes. And although drylands have historically received less research attention than their wetter counterparts, these are prevalent ecosystems both within our nation and across the globe. We can see here in this map how drylands make up the dominant proportion of our western U.S. systems, and taken together, drylands represent our planet's largest terrestrial biome. So understanding changes in these systems as well as opportunities for adaptation and mitigation of those changes could be critical at the global scale. In our country, as John said, because these shifts are happening across public lands, we have an opportunity to create understanding and to build tools that could be used at large scales relatively quickly. And these systems are in need of this knowledge and these tools because they are shifting so quickly, seeing mass mortality events in dryland systems for trees and other kinds of organisms, big changes to fire regimes and the ability of systems to recover following fire. So this area is really ripe for improved understanding and work with our manager partners to come up with solutions that we could use across vast scales. So how do we do this? How do we address these large issues and opportunities? We're really in the Southwest Biological Science Center trying to use a wide range of tools and working together with each other and with our partners, using experiments and modeling long-term observational data, the creation and contribution to science in networks, and with a real focus on restoration and revegetation. And one of the things that's particularly important to us as a research team is that we're co-producing this new knowledge and tools with the people that we think will be able to use them. And so we work really closely with our Department of Interior and other agency partners, also with state agencies, with the public, with practitioners and industry, to be able to come up with options for improved management that could hopefully help maintain and sustain these ecosystems and their functions in the face of such large change. Here on the left, you can see an example of some of our science from a project with the U.S. Fish and Wildlife Service, Bureau of Land Management, as well as oil and gas companies, where we're implementing a series of reclamation experiments on oil and gas pads across the Four Corners region of the Southwest to try to come up with improved reclamation and revegetation options that are climate adapted, that will work in the climate that we expect in the future. Here on the right, you can see a cool study that we're doing with the Department of Energy and contractors testing reclamation techniques at a Superfund site near Moab, Utah. With this study, we're able to incorporate watering treatments and to use the modeling John does and a network restoration program that Seth leads to be able to understand what's happening in these systems at single sites, but then be able to scale that to larger areas based on linkages to other data streams. And experiments are really at the core of a lot of the science that we do. We really like to push ecosystems in ways that we think are relevant to the changes those systems will expect, and then to ask questions about how the systems respond and what that means for management options. So on the left-hand side, you can see a warming experiment. In the top left, the only of its kind in any dryland, where we're trying to understand what increased temperatures could mean for these systems. You can see a drought experiment in the middle bottom there, a biological soil crust restoration experiment in the top middle, where we're trying to grow climate adapted biocrusts, which are communities of mosses and lichens and cyanobacteria that live in soil surfaces across the Southwest. And on the right, you can see us destroying the desert in ways that we think are relevant to manager questions, and implementing drought on top of that, physical disturbance, trying to understand system responses and what they could mean for opportunities to sustain these systems in the face of the physical disturbance and the drought and the warming that we expect for them. And network science is a really powerful way that we try to both connect with our manager partners to share knowledge and information, and also to connect across different ecosystems. So RestoreNet is a research network involving partnerships among lots of producers and managers and scientists, where we're systematically testing dryland restoration treatments and seed sources across wide environmental gradients of the Western US. There's 23 RestoreNet sites now across the Southwest, with more coming, where we can really try to understand what hinders restoration success in these dryland ecosystems, and what can we do about it to try to improve restoration outcomes through improved knowledge of system responses to change. And we use a lot of scaling techniques, including mapping and modeling. Scientists in our organization are conducting cutting-edge mapping of drylands that can be used to target habitat restoration and conservation decisions, can be used to understand how systems are changing, and to scale that understanding across much wider temporal and spatial scales, as well as to map land degradation and land potential, including in the upper Colorado River Basin. We're also using long-term observational data. You can see here Seth's use of National Park Service inventory and monitoring data, where he was able to go across many years to show the reduction in cover of cool season grasses here with warmer temperatures. These grasses are particularly important as food sources for wildlife and livestock. You can also see here increases in annual grass cover, including exotic annual grasses. These long-term observational data are so powerful in seeing changes across long time scales. And then we can pair them with experimental data. Here you see photosynthesis on the y-axis and reduced photosynthesis of this very important cool season grass, Indian rice grass. So we can pair what we're seeing on the landscape with mechanisms of why we may be seeing these reductions because of reduced ecophysiological function. Modeling and forecasting are also a critical part of the science that we do. For example, work that John Bradford has been doing to create a drought forecaster that can help managers make decisions about when to perform restoration or what to expect in terms of the increasing drought that we're seeing in these landscapes. We've also created a grassland productivity forecasting tool called GrassCast that attempts to predict the upcoming growing season's grass availability, so important for wildlife and livestock decision making, important for thinking about fire regimes and restoration options. And so what I hope you'll take home from the talks that John and I gave today are that drylands are big, important ecosystems that represent enormous amounts of public land that are changing really quickly in the face of climate change, but that there's not only challenges from these changes, there are opportunities for improved understanding and management of these vulnerable systems. And the biggest thing I want you to keep in mind is that we are a collaborative group of scientists who really want to work across disciplinary boundaries, across centers, across geographies, to be able to provide our nation with the best science that we have to offer. Thank you so much.
All right, excellent. Thanks, Sasha, for wrapping up a great series of talks today. So we've got about 10 minutes to, we want to save a little bit of time to do our quick wrap up at the end of the day, but we've got about 10 minutes now for a little bit of discussion, Q&A. So as before, please go ahead and raise your hands if you have anything you want to add. More specifically, if you have any direct questions for Sasha from her presentation, let's start there. But then if you have anything over and above related to just all of the talks in this last session, or even, you know, going back to some things we heard earlier today and maybe starting to make some of those connections. So anyone want to start? All right, there's a hand. Tanya, go ahead.
So two things. One, that the thing that I love about the drylands is that they are showing change so quickly. And I think that in the ag landscapes especially, there's so much management going on by individuals that it completely muddles our ability in a lot of cases to see what's happening. How do we separate, you know, tile drain expansion from climate, from, you know, changes in agricultural management? It's quite difficult. So the big expanses really help. And I will just give a pitch for, you know, this concept of soil data and microclimate data, because dare I say that because we don't, they're difficult to publish and keep calibrated and things like that, maybe they don't always get included when we're having to make choices in terms of cost. And I think that there's a lot of evidence at this point that they're a key piece of our puzzle, that we don't always have the same replication as other stuff. And so maybe that's a huge opportunity.
I just second that. I definitely agree. I think that collecting those kind of soil and climate data on site allow us to extrapolate and scale and build that larger cross-system understanding in a way that's so important. And so for a lot of the experiments that we have that are more consolidated, we totally do those things. And then the networks, as Seth's writing, it's kind of a collaborative of convincing other people to be involved too, and doing it on a shoestring, Seth leading it, and trying to put those pieces together. And so I think prioritizing that, like you're saying, is such a good idea, and reminding ourselves of the value of those data, not only to understand what's happening at the place where we're measuring a lot of things, but to be able to turn that understanding into something larger that can mean something for places we can't measure, or because of cost or whatever. So I think that's a really good point.
Thanks, Tanya. Thanks, Sasha. Anyone else? I'm looking through the chat. I noted Judy's comment related to vulnerabilities and tipping points and trying to find those connections across our different ecosystems. I think that's something that came up, you know, in our coordinator group as we were having these discussions about maybe where to start, is that vulnerability to change.
I won't respond to everything, but I love that idea too. I think that, you know, thresholds and looking for kind of an accelerating rate of change through time is very important to our partners. It's what everybody's really scared about. And it seems like a theme that joins all of our ecosystems together, that we are seeing change or we expect change. And so how do we create the knowledge and the tools for the people that we work for to be able to meet that change with some tools in their pocket and some hope in their hearts.
Great. Nick, I think you're next.
Yeah, I would just let everybody know that, probably no surprise, but the organizers agonized over every part of this for weeks and months. And you wouldn't believe how we discuss and rehash and go back over just even one sentence. But one of the things that came out of that was that we picked habitat vulnerability because habitat is, broad enough that almost anything can fit into it. But similar to what others have said, I've been impressed with how much similarity there is, deeper than even just habitat, between even wet and dry ecosystems. I mean, I'm just seeing all sorts of ideas that made me think about those things differently than I did before what I heard today. So I think this is, it's been really interesting. Thank you.
Thanks, Nick. Mike, go ahead.
Yeah, and I just emphasize what Nick just said. We have been talking about this, and this has been both very informative and also challenging in that it's given us a lot to think about. And what I've seen is that in a lot of these systems, you folks and others have done a lot of thinking locally about what's happening and what's likely to happen and why, and how we could go about quantifying the rates of change or the likelihood that there will be tipping points and perhaps forecasting what the future holds based on different management choices that might be made. And I'm wondering if one of the things that we might want to spend more time talking about is whether we can, whether there is a standard approach to doing this across these systems that relies on, the commonality and the sorts of questions we're addressing in each of these individual systems. And I was pretty impressed by Stephanie's presentation in particular because of the thought that seems to have gone in her group to setting up a sort of standard for analysis for this. And I wonder if we can generalize it. So I'm assuming that there's some chance that some of this has been done before, but if we can find the sweet spot where it's an addressable issue and we have the resources to do it here, then I think it's something we ought to talk about.
Thanks, Mike. Nick, again, go ahead.
Yeah, and I just want to say one more thing is that what I would like everyone to, I think we're kind of melding into our final discussion little group for today, but I would like everybody to think about two things from two perspectives. Based on what you heard today, what do you think about your tools and approaches and where you think they might be applied elsewhere? And then I want you to look at it from the other perspective of what you might have heard somewhere else that you hadn't thought about that might be applied in your location. So think about it, that arrow moving in both directions. That's where we want to end up on Friday evening. And I'll spend a lot of time during the next 3 days bringing that point out, because now you've heard a lot of really good stuff, and start critically thinking about how that might be applied in conjunction with the intent of our workshop.
Yeah, great, Nick. Tanya, go ahead.
I was just going to say that the examples of the decision support tools, I think, are great, and hopefully we can use them to show some of our stakeholders as examples, because I feel like in the Great Lakes, for example, there is a lot of emphasis on small study sites and individual monitoring sites, but sometimes the mechanisms with which to integrate all of them do fall lower in the priorities. Sometimes we don't really have a good example to put up in front of people in terms of saying, this is the benefit you get by providing that context, and maybe, I don't know, maybe that's something that we can use. So I'll be calling.
Thanks, Tanya. Judy, go ahead.
Yeah, it just occurs to me that we need some kind of common currency to talk across systems. And, I remember a while ago, Sasha, we talked about carbon and how we can, talk to each other. And I love the fact that arid lands are a part of this, and that we're talking again together, which to me is just always very eye-opening. But I'm just trying to figure out, like, if this, like tipping points or vulnerability to change, and which part of the system is most vulnerable. And if we start looking at generalities across these systems and come up with some kind of a currency, maybe we'll really understand that we're having much greater similarities than differences, and And that's something that, we get into our silos when we're in different types of ecosystems. There's a lot of us wetland folks that talk to just, each other. And, I try to talk to all kinds of people, but, you end up, talking to a lot of the same people. And there's research on creativity that shows that really stunts your creativity, actually. So I just think that there's great opportunities to reach across systems and look for commonalities. And maybe we need to think about what the currency should be that we really focus on. Thank you.
Yeah, thanks, Judy. I think that's an excellent point. And I think hopefully we've started part of that right now, by just holding this first workshop. I think that's one of the things that Ken mentioned, kind of our objective number one was to get all of you together and work in different spaces, different topics, and try to have some of those conversations. So, all right, so we're about ready to wrap for today. I'm going to turn it over to Ken and Nick to kind of wrap us up. But before I do, let me just check with any of the other coordinators to see if you have any final comments for the day. Anything you want to chime in on before we kind of start our wrap up?
Huge thank you to everybody.
Thanks.
Yeah, really good notes have been generated. So I think we'll have a lot to work from.
All right, perfect. So with that, I'm going to transition over to Ken and Nick to kind of wrap us up for the day and talk a little bit about prepping for tomorrow.
Okay,
Thanks,
I'll start first with some general comments, and I think Ken is going to talk to you a little more about Jamboard and any homework you might feel energized to do tonight to prepare you for tomorrow. But one thing I just want to back up a second and say, after that last discussion and everything I've been seeing in the chat, if this workshop accomplishes nothing else than to get all of you together and hear about some things you might not have otherwise heard, then it is a success. I mean, the networking opportunities and the professional relationships and communities of practice that can be increased here, I think that there's a lot of potential there that I really enjoyed. Main thing I want to ask you to do over this evening, hopefully over a glass of wine or beer or beverage of your choice, since we can't be together and do it in any way else, is to be thinking of any clarifying questions. And in my first session that I'll facilitate tomorrow, we'll spend the first 30 minutes or less if we need less, but I want you to think of any clarifying questions that you would like to ask of any of the presenters, because we had relatively short time today, and you will have had time to mull some of this over in your mind. So take some notes, over the evening. Think about, I would like to jump into that first part of the session really rolling and get that behind us, and then spend the second part of that first session tomorrow. We have 2 hours total of reflecting on what we've heard. And I've asked some, what I hope are some provoking questions to make you think about how this might start to lead us down the road of some common tools and approaches that we might think about. We already have some Jamboard questions set up that Ken's going to go over in just a second. But think of our main workshop goal, the end of the day, Friday, 3 to 5 or whatever number is magic, tools and approaches that we might pursue in a second workshop to actually accomplish, and think of it from a pilot standpoint, a proof of concept, whatever you want to call it. And also think about, as mentioned earlier today, other things. What might be aspirational for the longer term? What might be done without any further discussion by us? Just that something that might pop up so obvious that we don't need to pursue it further. We should get those things going immediately. So just keep your thinking hats on over the evening, and then we'll charge right into that tomorrow. Again, I also want to add my thanks for this. I know it was intense today with a whole lot of presentations, but all of you stayed engaged. We had 8 to 13 people watching on our live stream site, so I hope they got something out of it. And I also appreciate just the ability to stay on time, because that helps the observers that are watching us. All right, Ken, I'll let you finish up.
Thanks, Nick. So I think that's a really good wrap up. So I'm going to be very, very brief. I think from a high level, my sense today is I actually feel like we got more accomplished than I thought. I really thought this was going to be 16 presentations all over the place, and we'd be struggling to knit together the commonalities already. I think we've gone the other way. I think everyone came in with that mindset of let's begin to connect the dots. So much appreciation. I think we've gotten really far. So Breck, if I could get you to, one, pop the link to the Jamboard in, and then two, just open it on, share it on your screen. So here's the idea. I love chat. Chat's really effective in a meeting. But what we wanted to do was to take a couple of the discussion questions that Nick had prepared, or that we prepared, but are in Nick's first session tomorrow, and we really talk about what did we learn. And so many of you have probably used Jamboard. It's just a collaboration tool. That's all it is. It's a way to capture feedback and organize it. So if I go back and look at our chat session, it's kind of a chronological sequence of comments. The idea here is, can we organize our thoughts a little bit? So if you open the link, I know we had some discussion about accessing the link and popping in. What we've really done are just set up a series of slides here where you can, as you organize your thoughts and think about it, you can actually start to capture some notes here. So, the first, and I'm not saying this minute, I'm saying if you can do some tonight, if you can do it tomorrow, whatever, that's fine. We didn't announce it until now, just because we didn't want people working on it while others were giving their presentation. So it's a great opportunity to jump in and say, well, here's what I heard about, in this case, this slide is the most vulnerable habitats. And I think the next slide starts to ask for commonalities. So yeah, which approaches are we conducting that are kind of more common? And just a series of just exploratory questions we're going to work through tomorrow. And I'll leave it at that. It's great to begin thinking about it and to begin organizing your thoughts around some of these discussion questions. And then tomorrow we'll go ahead and we'll go, we'll see how the discussion takes us. So Breck is showing you, it's very easy to click on a sticky note on that left edge. I think it's the fourth one down is a sticky note. Pops one open. You can change the color of it, and you can put your notes in there, and you can just click save, and it'll show up on the Jamboard. So it's just a great way to gather input. So that's the request. Think about it. If instead you say, I'm going to organize my thoughts overnight, tomorrow during the discussion sessions, I'll drop notes, and I understand that. But we've had a lot of commonalities already developed today. And so I just wanted to highlight that Jamboard as an opportunity to pre-populate it, or you can wait till tomorrow. So with that, I would say you can stop sharing it. Let Breck and I know if you have any trouble. And with that, Nick, I think that's our wrap up. I feel like we've climbed a pretty good mountain today. We've got 2 more mountains in front of us with day 2 and day 3. So we'll look forward to seeing everybody tomorrow at noon. Any final thoughts, Nick, you wanted to offer? All right. Thanks, everybody. Take care. We'll look forward to talking more tomorrow. Great day today. Appreciate it.